With the help of natural language processing, you can communicate with computers in a human language or in a natural language. So, if you have seen any of these chatbots, such as Cortana or Siri, what you're doing is you are communicating with a machine in a human language. And this is the field of natural language processing. So, understanding the importance of NLP, we have come up with this tutorial on natural language processing for beginners.
Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.
And in today's tutorial, we will learn about what is NLP, that is Natural Language Processing. And then we will have a look at some of the data manipulation using NLP. And then we will have a look at bag of words, engram, naive bias.
Okay, folks. I am Manish Gupta. I work as a senior applied scientist at Microsoft. I also work as adjunct faculty at IIIT Hyderabad. So I guide a few MTech and PhD students there. And I also work as a visiting faculty at ISB. So recently I have started teaching a few courses there. Today I am going to talk about natural language processing. So, but it's not going to be as mathematical as that. It's going to be fun. So I deal with a large variety of people. So essentially, from folks who can do as mathematical and more mathematical stuff like that, to folks to kids also. Right? So essentially, just ask questions as you have, and just make sure you understand and make the best use of your 2 hours. Okay. So we will start. So natural language processing. So how many people have heard about this phrase earlier, natural language processing or NLP? NLP might be more common than natural language processing, right? About say 1/4 or 1/5 of you guys, right? And has anyone worked on any natural language processing system? Any text processing? Any natural language processing? No? Okay. So that's like a perfect thing, because these slides are also going to introduce the thing. Okay. So so this is going to be pretty much the agenda. So we'll start with what is NLP. I'll talk about a few things called as tokenization, normalization, stemming, and so on. Then we will talk about sentence segmentation, phrase identification. Then something called as word sense disambiguation, and finally talk about parsing. But more or less today it will be more of slide stuff with a little bit of demos here and there. Okay? So let's start with what is NLP. Interesting. So Google search can be considered as one NLP system, which does some sort of, so basically any search engine is a NLP system. In that sense, you can call it an NLP system vaguely. Text mining, yes, some system which does text mining is an NLP system, right? Yeah. Artificial, so all these words, right? Data science, data mining, artificial intelligence, deep learning these days, or information retrieval are all related. Okay? But there is a machine learning, they are all related, but there is a slight difference in all of them. Okay? So an NLP system is any system, as it says, natural language processing. So it's a system which takes natural language and processes it, as simple as that. So anything that takes natural language as input and processes it is called a natural language processing system, practically. Okay? So by processing, it means, of course, the system should be of some use, right? So if it produces another transformed natural language, or it produces insights, some insights out of natural language, it's a natural language processing system. Okay. So a search engine is also a natural language processing system because it takes natural language queries, right, or queries that you put in, and gives us insights in terms of results. Okay. So, but practically when people talk about natural language processing systems, they talk about a large umbrella of tasks which fall under this umbrella. Okay. So I'll start with a few examples, or the interesting part in this slide. Of course, I'll not read everything on this slide. So NLP is a process of taking natural language text as input and output some insights on natural language from it, transform natural language. Okay? So, why are we having this lecture? Mainly because this course is so focused on applied stuff. So it's a natural language processing systems are critical components across various verticals or various segments. So whether it is finance or insurance or media, e-commerce, retail, oil and gas, anything and everything sort of has data these days and requires natural language interaction. So it's basically a critical component across all of those. So whether it is finance search, so search for various news about companies and therefore try to predict stock market prices and so on, right? Entity matching, call center analysis, or any of those applications, they all require natural language processing. So one of the applications is say e-commerce, say Flipkart, right? If they want to figure out what are people saying about a particular product, or they want to figure out what are people saying about their service. So what the Flipkart can do is to really look at the reviews that they have and parse them, try to figure out sentiments of people in those reviews, and then figure out what particular aspects people are happy with, what aspects people need improvement, or Flipkart needs to do improvement as people are suggesting, so on. That is also text processing or natural language processing. Right? It's so important to Flipkart to know what to improve on. So basically, it's a critical component across various applications. Right? So in the next few slides, I'll show you popular natural language processing systems. So basically, things that have proven to the world that yes, NLP is required, and if NLP is done nicely, it can do a lot of things, a lot of interesting things. Right? So how many of you know about IBM Watson? IBM Watson? So for others who do not know, should go back and search for it. As simple as that. So and this is my usual advice to people. To learn anything, if somebody is saying things that you can't understand, then you just go back, and fortunately we have search engines, right? So just search for it. Okay? So IBM Watson is this big natural NLP system that IBM came up with. Okay? IBM Watson became popular in 2011 when it won this particular game called Jeopardy against the best guys in the world. Okay? So what is Jeopardy? So Jeopardy is this quiz kind of game. So where typical Britannia quiz kind of things that you saw on TV at some point, it's a quiz kind of competition where there are like many participants and the quiz master asks various questions, and whoever can answer fast is the one, and correct is the one who wins points. Right? So IBM Watson is the system which can take questions of this form. William Wilkinson's An Account of the Principalities of Welsh and Manchuria inspired this author's most famous novel. So who is this author is the question. So now, of course, it's a quiz question, memory-based questions in that sense, right? And computers are very good at storing things, right? At memorizing things, right? It's just about figuring out a nice way of querying those memories or those facts and then showing up the right answer. In this case, the right answer happens to be that guy. So, IBM Watson actually won this game against the best people in the world, and that's when people started realizing, oh, there is a good potential for automated NLP, automated natural language processing system. And these systems can do something significant. So another example of a natural language processing system are information extraction systems. Okay? So information extraction systems are a group of systems by themselves. So they are things which take unstructured text, as it is called, and transform it to some structure. Okay? So let me show you this example of an information extraction system which will make it clearer what is unstructured text and what is structure out of it. Right? So this is a typical email. So this is an email, there's a subject, there's a date, and there's a to in it, and there's the email body in it, right? So, hi Dan, we have now scheduled the curriculum meeting. It will be in dates 1:59 tomorrow from some time. Right? So now, what can we extract out of it? What kind of structured stuff we can extract out of it? Anyone? Meeting, place, time, yeah, awesome. So we can actually imagine, so I don't know what all email clients you use, but imagine an email client which takes an email of this form and automatically suggests creation of a meeting entry in your calendar. Right? How about that? So essentially, it automatically understands that there's a calendar entry here and automatically extracts those things. So what is the event? What is the date? What is the time? Date. So it's not really very trivial. It says we have now scheduled tomorrow, right? So it sees the date of the email and then infers that tomorrow is Jan 15, 2012 in this case. It puts that in there, start, end, where, and so on. So these are information extraction systems which take unstructured piece of text and come up with some structured stuff which is useful, right? So information extraction systems are a form of NLP systems. So if you think of it, still again here you have a natural language input, an email, right? And the output is some insight out of it. So the insight here is the calendar entry. It saves time for a lot of folks to have frequent emails and get many of those emails. frequent tweeting. So another kind of application for such NLP systems is in sentiment analysis. The same case, the Flipkart case that I talked about, right? But a little bit more in detail. So consider this case where people write a lot of reviews. Right? So for a camera, say for example. So I want to know how good this camera is doing in the market. Right? So what will I do? I will go to its Amazon's webpage, look at various reviews, try to see what are people talking about. Of course, as a human, I can do it very nicely. I can figure out, oh, people are talking about its weight. They're saying, oh, this is so light in weight. Awesome, right? Imagine an automated system trying to do that. Right? Trying to read sentences, figuring out what aspect is being talked about, and then for every aspect, try to look for sentences which talk about that aspect, and try to sort of extract whether they're talking positive or negative about that, and therefore come up automatically with good or bad about that product, and therefore come up automatically with the rating associated with that aspect of the product. Now, such a sentiment analysis system is a NLP system because it basically takes natural language review text and outputs something of that sort, an insight, a structured insight, so to say. Well, then there are other systems like machine translation systems which take which take natural language input and then transform it to another natural language. Okay? And then there could also be semi-automated machine translation systems which take natural language input and then suggest next word that can be used by a human translator. Right? So sort of help the human translator to come up with the next possible word. So all of those systems are like very awesome systems. Now you won't learn how to build those systems in 2 hours. Okay? But these are the things that can be done using NLP. So if you know awesome NLP, you can actually spend time and build such systems. Okay? So these systems depend on some basic tasks. So basic tasks in the sense things that have applications in those systems. Okay? So what I have done here is on this slide, sort of try to capture as much as I can about text-based NLP systems. Okay, and these are grouped into 3 parts, right? So so there are 3 parts. There is this green, yellow, and red parts. So the green part is the one where systems exist, NLP systems exist such that they perform really well. So they perform like 90% accuracy and they can actually be used nicely. There are commercial softwares to do those tasks and so on. So the yellow ones are the ones where there are some commercial softwares but the accuracy is not very high. It's like about 70-80% accuracy. And you can use those systems for a larger system, where this thing is going to be used as a signal, but you cannot depend completely on these systems. And the last ones are the systems which are in research. So basically saying that there's no commercial software available for them. And even if there is commercial software, it is not general software. So basically it can work for certain restricted domains, but it doesn't work generally. So we'll just go over them one by one in brief. So spam detection, all of us have seen how powerful spam detection is in our Gmail boxes, on your local Outlook clients or any of your email boxes. Right? So spam detection sort of works reasonably well. Junk is classified as junk and good emails go to good emails, right? Inbox. So then there is a task called as part of speech tagging. So all of us have struggled through this task in schools, right? So essentially, the teacher would give us a sentence and ask us to figure out parts of speech in it, right? What is a noun, what is verb, what is adjective, and so on, right? And then there were certain things which are always confusing. You didn't know what to do. So imagine an automated system doing that. So automated system taking a sentence and then automatically saying, oh, this particular first word is an adjective, second one is also an adjective, maybe third one is a noun, and so on. So it's called a part of speech tagging system. So I'm sure you guys have kids in schools. You could probably try one to solve one of the assignments of your kid. Yeah, it's fun and it's not very difficult to do. I'll show you a demo today, and anyone can just do the demo very easily. Okay? So that's that. Then there are systems which build on top of part of speech tagging and are called as named entity recognition systems. Okay? So these are systems which try to figure out named entities. Now, what are named entities? Objects, real world objects. So things like persons, organizations, locations. For example, Einstein met the UN officials in Princeton. So Einstein is a person, UN is an organization, United Nations, right? Princeton is a location, so on. So these systems are reasonably good. So these systems are like 90% accurate, so on. So while there are these systems which are not very accurate, but there are interesting things that one can do with language. So for example, sentiment analysis. So all of us sort of know this thing, right? Everyone has heard about sentiment analysis somewhere or other, right? Everyone has vaguely heard about it, right? So and it can be used to automatically figure out ratings given a particular review text, right? or it can be automatically used to figure out how good a product is faring when it is recently launched. Right? If the company has recently launched a product, you might want to see what people are talking about the product. So essentially, are they happy with the product? They're not happy with the product. What aspects of the product they are happy with? They also do comparative analysis. So what is the feature compared to the competitor that people are happy with, and so on. That all falls under the sentiment analysis bucket. So then there is an interesting task called as co-reference resolution. So this is really important when you want to really understand automatically a piece of text. Okay? So imagine you are reading some Harry Potter story, okay? And there are many references like he, she, and it, and all those pronouns. Now sometimes it gets confusing as to even for a human as to what he is meant here, right? Basically, which person is meant here? Okay? So imagine doing that task automatically. So automatically trying to figure out this pronoun refers to which person, which was mentioned earlier. Okay? So that's what is called as co-reference resolution. So for example, in this particular case, Carter told Mubarak he shouldn't run again, right? So now he could actually stand for Carter or for Mubarak. So, as humans, we can figure out easily it stands for Mubarak. But for an automated system to figure that out is a little tricky. Okay? So that's called as co-reference resolution systems. Okay? Then the other one is word sense disambiguation. So word sense disambiguation is important. Again, when you want to understand text and you want to sort of make use of this understanding somewhere. Okay? So for example, I need new batteries for my mouse. Now, what does mouse mean here? So of course you can go back to a dictionary. Dictionary will give you two senses for the word mouse. It's an equipment or it is an animal. So which particular sense of the word is meant in a particular sentence is what is captured under word sense disambiguation. So where is word sense disambiguation useful? Any uses that one can think of such a system? If you have such a system, where can you use it? Okay, can you elaborate more as in what can you do with it? So how good or how bad that you can sort of probably decide based on sentiment somewhat or by looking at the syntactic structure and so on. I mean, when I say word sense disambiguation, right, it's not going to explain more. And what it is going to do is to really figure out senses that are available in a dictionary and then figure out, which particular sense is being used here. So what you are trying to say is that if you can figure out some elaboration of that particular word, right, which is not the task here actually. So it's a little different. Yeah. Correcting your sentences in online help. We'll come to online help. How do we correct the sentences using word sense? Yeah, but no, I mean here actually the interesting part is both mouse have the same spelling. So I mean it's again not going to be, so that's good that you're pointing out these related things. So it's still different from a spell corrector. Okay? So it's not going to be similar to a spelling correction because whether and whether will have different spellings. But here both the kinds of mouse have the same spelling, right? So now imagine reading a newspaper, right, where somebody says Gandhi went to Bangalore and made this speech. So now you want to figure out, I mean, so you want to figure out which Gandhi is meant here. Now it could be like Rahul Gandhi, it could be Sonia Gandhi, and so on. So I mean, of course, Gandhi does not exist in a dictionary, but you can then consider Wikipedia as your dictionary, right? And then try to disambiguate, which Gandhi is meant here. Okay? Now, if you can disambiguate that one, maybe you can give the user a functionality that while he is reading a web page, right, you can possibly say, if you basically want to know more about any of those things mentioned in this document, you can just right click and say, highlight Gandhi and right click show me more insights. You can show a nice visualization there. Gandhi was born here and this and that. So in fact, a related app is a Google Now on Tap. Has anyone used Google Now on Tap? No? So it's a nice app where you can sort of download the app. If you download the app, right, and say you are discussing with your friend on WhatsApp about a recent movie. Okay? You're discussing, let's go and watch this movie. Okay? So you have the movie name, Ae Dil Hai Mushkil. Okay? And now what happens is, if you long press the center button on your mobile Android phone, right? So what it does is to capture whatever is being visible on your phone right now. And then what it does is to really take that particular entire content, figure out what is the most interesting entity there. So for example, the movie name is most interesting, and it will show you more insights about the movie. Who is the cast, where it is being showcased right now. It will get data from bookmyshow.com and show you next time slot available where you can book the tickets and so on. So this is where these things could be useful. right? So essentially, if you can do word sense disambiguation, if you can, suppose there were like two movies with the name "Ae Dil Hai Mushkil." Now you don't know which one is the right one, right? So figuring out the right one based on the context, if you can figure out the right one, then you can actually show timings for that movie and so on. So that's that. The next one is parsing. So parsing is a task where you basically take the sentence and try to figure out the entire grammar structure out of it. So in the sense, of course, the first level is part of speech tagging. So you basically figure out what are the parts of speech of each word in the sentence. But then you also try to figure out phrases. So hey, this and this word, the window, can be combined together to come up with a noun phrase, the window, right? Or from the window, can all three words can be combined to come up with a prepositional phrase and so on. Okay? So that's called as parsing. Okay? So the next two we already talked about, machine translation and information extraction. So these are all systems where there exists some of those commercial softwares and you can sort of use them, but they're not like 100% accurate. So they work reasonably well, 70-80% accurate. And so for example, if information extraction systems were 100% accurate, they'll take your emails and automatically create calendar entries for you. They won't ask you, hey, can I create a calendar entry? Because there's a chance that you'll do some errors while getting any of those fields. So that's that. The last one are quite interesting. So, and these are really challenging problems to solve in general. Like there are some question answering platforms, for example, systems which are very good in a particular domain, but not in general. So what is a question answering platform? Anyone? So, if everything was solved by Google, nobody would really go and ask questions there, right? So they would essentially get answers directly. And just search, get answers. Nobody would ask questions there. For example, if you have a question of that kind, how effective is a particular medicine in reducing fever in patients with a particular kind of illness? So, if you just search on Google, especially such long queries, you will really not get good results. Okay? And that is why what you do is to really go to, any of those platforms, Quora or Stack Overflow, and ask those questions. Right? So, imagine an automated system automatically answering such things. So in the sense, now, of course, the system does not have knowledge, so it cannot create knowledge, but it can at least use knowledge which already exists. So say, for example, if somebody has answered a similar question, can it figure out a similar question and automatically show the answer that somebody has given there to the guy who is asking now? So such a system, now, there exist some systems, there are efforts in that direction, but they are not very effective still. Still, you depend on Yahoo Answers or on Quora and so on to really ask interesting questions. And just hope that some human would come, some guy would come and answer that question. Right? So then there are chatbots. Okay, so let me go to the last one since a lot of people talk about chatbots. Right? So there are these systems which are interactive in nature. The difference between question answering and these chatbots is that question answering systems are not interactive. You ask a question, somebody answers it. That's all. So chatbots are interactive in nature. So where is Citizen Kane playing in San Francisco tonight? Okay, so and then maybe this chatbot will go ahead and tell you where it is, and then also ask, do you want a ticket? And the conversation can go on. So in the sense, the guy can ask, can you please book a ticket for 2 for me, right? So and then this guy asks, what is your credit card number and so on. So conversation can go on. So those are chatbots. And of course, you have your, the current chatbots that we have are quite restrictive in their capabilities, right? So if you have used Siri or Cortana or Google now, you can ask simple things like weather, or you can ask them to play a song or sing a song or tell a joke and so on. But that's it. They really cannot keep the conversation going, right? So it's very easy for you to just fool around with that, and then 1 or 2 steps you can automatically figure out what are the limitations of these systems. Okay? So that's that. So the other two are paraphrasing. So remember in colleges, you would basically copy assignments from one another, right? So one guy would solve the thing, other guys would just replace the variable names and then submit the stuff, right? So the teachers are also not very competent, so they would not recognize it very well, or they anyway knew that you're copying, so they didn't bother to do any detection, right? Plagiarism detection, anything of that kind. But now imagine a system which sort of looks at a sentence, XYZ acquired ABC yesterday, and then says that, well, there's another sentence, ABC has been taken over by XYZ, and says, oh, by the way, both of them mean the same thing. Okay? So basically saying that in a class of 50 people, if I ask you to write an essay on Independence Day, and if all of you write similar things, right, they may not exactly have the same words. In fact, the words could be different. So acquired actually also means has been taken over, right? So the words could be different, But if it is exactly the same in meaning, I could figure that out using paraphrase detection systems. So paraphrase detection is that task. So given two sentences, automatically figuring out if they mean the same thing or they entail the same thing. Okay? So that's that. And the last one is summarization. So of course, there are many summarization systems. In fact, there used to exist one in Word also. So Microsoft Word had a summarization system. So given a large document, just summarize it for me, right? So where you could really specify, summarize in 10 sentences, in 50 sentences, and so on. But these systems are pretty limited. Okay? They do what is called as extractive summarization. Okay? The kind of thing that the teacher would tell you not to do. So if you remember going back to school, when teacher would ask you, here is a bunch of paragraphs, summarize them, right? The teacher would tell you, don't copy words and sentences. You have to understand the meaning and then write it in your own words. If you remember from those days. Okay? So, but the current systems can only do extractive summarization. So they basically look at sentences, figure out which of them are important, okay? And then they just put out those sentences. Okay? Of course, there is a little bit of more intelligence in it, in the sense those sentences should be coherent and so on. Okay? And there should be some linkage between the sentences that you output and so on, but there's still extractive summarization. But what would be very nice to do is something called as abstractive summarization. In the first, understand the meaning and then write it in your own words in short. Okay? So for example, in this case, the Dow Jones is up, the S&P 500 jumped, housing prices rose. All of this really means that the economy is doing good. Okay? So now this one really requires an automated system to understand what it means behind all of these things, and then conclude that when the economy is doing good is the shortest summary that I can provide, a very nice abstractive summary. Okay. So overall, this is what is studied under the umbrella of natural language processing. So essentially, if somebody says they're building a natural language processing system, practically they must be touching one of those tasks. Okay? So besides those, there are also other tasks, okay, which are related to natural language processing. Okay? We will not go over all of them. But one comment that I have is natural language processing tasks don't just relate to text. They could also relate to images and also to speech. So for example, if I go outside and take a picture and then tell you that, hey, give me all the names of the shops that I can see outside, right? Give me a text file which contains all those names. So now that is also a natural language processing system. You have taken a natural language which exists on those images, all the shop names, right? Maybe done a OCR, optical character recognition, and then gotten the inside, the names of the shops. So that's that. Similarly, speech recognition is also a related system. So where you take input in the form of speech, right, and then output the transcribed text. Okay? So all of those are also interesting systems, but for today we'll just stick to text-based natural language processing systems. So it depends. So of course the tools exist to handle various kinds of things, but the way you use the tool is important. For example, CT scan and MRI scan, or even eye scans, right? If they don't have text, then it is not applicable, right? So it's basically understanding something from the images is a separate thing then. So it's basically then image processing or computer vision people guys do. So if it contains text, then it pertains to natural language. Does that make sense? So now why is processing? So now we talked a lot about various applications of natural language processing systems, right? So now we need to really go into a little depth, right? And sort of understand, if somebody asked us to build one such system, what is it that we need to know at least, right? So this slide just captures what are the challenges in building such systems. Okay? So also before going into those challenges, one thing to note is natural language is the language that we use. English, Hindi, Marathi are all natural languages, right? Or Telugu and so on. Right? Versus formal language, which is the code that we write, right? For example, C, C#, Python, Java are also languages, but they are formal languages, right? And the biggest difference is that formal languages follow a particular code. They have a rule set, right? And they have a limited set of keywords and so on. So basically, you can easily find patterns in a formal language, right? But in a natural language, by the definition, if there are rules, then it will be like a robotic or a formal language, right? So therefore, there must be things that break rules. Right? So there must be things, that make it natural, really. Right? So, and that is the problem when dealing with natural language. So if there are things that break rules, they cause issues when you're building systems on top of it. So, and these are the various challenges that sort of break rules. So for example, when you are writing a for loop in C, for I is equal to 0, I is less than 10, I plus plus, it means the same thing. I mean, it cannot have two different meanings. It has just one meaning, that I is a variable, you have to go from 0 to 10, or 0 to 9, less than 10. But language is often ambiguous, right? Natural language is often ambiguous. For example, read these and read it from a mindset of trying to figure out other meaning, right? So teacher strikes idle kids. Okay? So this guy is doing nothing and strike. Okay? Or I could also read it as teacher strikes idle kids. So teachers are on strike and therefore kids are idle. They are doing nothing. So let's take another one. So hospitals are sued by 7-foot doctors. Okay? So it's not the doctors are 7 foot. It's just that they work on foot-related diseases. Okay? So I mean, the way you read it conveys a different meaning. Right? So essentially, there is ambiguity in natural language, which causes issues when you are trying to do various kinds of tasks on top of them. Then there is also this concept of non-standard English. Right, so not always when we write English, we mean English, we write English, right? So essentially, so of course news articles contain English, but if you look at the SMSs that you send or the tweets that you write, they are not English. They are semi-English. They are often code mixed, so to say. Many times they contain Hindi and English, or Telugu and English, or in other countries Spanish and English, and so on. So, and many times they have various kinds of short forms like you taught us to and so on. Okay? And of course emoticons, right? So, but when it comes to natural language processing tasks, now imagine doing sentiment analysis on top of tweets, right? So, which is a natural language processing task. It's challenging. Why? Because now you really need to figure out what this symbol means, right? So the symbol has some meaning and various, and now there are so many smileys that you want to sort of decode those smileys, convert them to actual natural language text, and then figure out, oh, there is a positive sentiment here, or there's a negative sentiment here, and so on. Okay? So then, the next one is segmentation issues. So when processing any natural language piece, right, you have to work at the word level. You need to extract words out of the text. Okay? Now, and that is called as usually segmentation or tokenization. Okay? So in English, the usual thing is that you just look for word separators in terms of spaces. If there is a space, you separate and get a new word. But the problem is that apostrophes and hyphens are culprits in English. And so basically, these guys cause a lot of problems. For example, look at this particular phrase, the New York New Haven Railroad. Okay? So now, the right segmentation is here, not this one. So basically, you don't want to keep New and York separately. Okay? But what happens? I mean, if you just look for spaces, then this is what happens, the first one. So therefore, I mean, which is another challenge. So it's not just with English. In fact, in English it is much easier to do segmentation. For other languages, it is much more complicated. Okay? So, and we will look at that later. So then there are idioms in a natural language. There are no idioms in a formal language. So in a formal language, if there is a higher level construct, it sort of uses the lower level basic constructs, right? So, but in a natural language, there are things which are composed of words, but they don't mean the words that are contained in them. For example, throwing in the towel doesn't mean throwing in the towel. It means giving up, right? So if you pay attention to idioms in school again, you would sort of appreciate that idioms are things which are beyond the words that are used inside them. So how to understand them and process them, especially again for sentiment analysis kind of thing. So if you are depending on words for analyzing whether the sentiment positive or negative, then would you call this thing as negative sentiment? You would not. Throw in the towel has no negative word in it. But it's a highly negative thing because you're giving up. So it's basically negative sentiment stuff. Yeah. So then there are neologisms. So in a formal language, when a language is defined, you have set of keywords associated with it. Right? But natural language, it just evolves over time. New words keep coming in the language as the language evolves. So then word knowledge. So in a formal language, when you write something, it basically means exactly what is written, and there is no other knowledge required. Okay? So, for example, if your Java code is compiling, it must be correct. Okay? It is just perfectly doing fine. Okay? But in a natural language, right, there might be sentences which are perfectly okay with respect to part of speech tagging and so on. Okay? I mean, if you want to compile an English sentence or figure out whether it is written correctly or not, you would look for English grammar. I mean, well. These verbs go together, look for part of speech tags and so on. But there could be sentences which are perfectly grammatically correct but make no sense in the real world. For example, Mary and Sue are sisters of each other is perfectly okay, but Mary and Sue are mothers of each other is not okay. I mean, although it makes perfect sense from a syntactical perspective, right? From English grammar perspective, it's completely okay. Mary and Sue are mothers of each other, so it's fine. I mean, there's a noun phrase, there's a combination, and so on. Subject, verb, object, all are in place, right? but based on the world knowledge, we know that it doesn't make sense. That's another challenge, that when you're doing NLP, you have to also incorporate world knowledge somehow. So there must be some knowledge base which you should include so as to understand that these facts are possible and these particular combinations are not possible. And then the last one is tricky entity names. Okay? So for example, if this was not italicized, right? If I had just written it as "There is a bug's life playing," what would you get out of it? Nothing. Right? I mean, what do you mean by a bug's life, right? So, but if I italicize it right, it sort of means, oh, it is probably some play or a song or something like that. A bug's life is probably some entity name. Okay? So these tricky entity names make it very difficult to parse this language and try to figure out, oh, what it means here. Okay? So, a similar example I can give you about the same app that I described. Right? So let's recall this app on the phone, which sort of looks at your current thing on the phone, tries to figure out the most prominent entity. So remember I told you about WhatsApp example, and there is a movie name there and it turns up at the top. Right? So now we were doing this and we're building this kind of app, and what happened was now two guys are talking to each other, right? There's a guy named, let's give some name. What's your name? Rajesh, okay? There's a guy named Rajesh who's talking to Shahrukh, okay? There's a guy named Shahrukh, and they're talking to each other. Now what happens is, now Shahrukh is Shahrukh Khan. I mean, the point is that the system automatically tries to figure out and sees Shahrukh mentioned many times because Rajesh said something, Shahrukh said something, and so on. Okay? And then it just triggers for Shahrukh saying, oh, Shahrukh must be the most important entity, and then links it to Shahrukh Khan. Now that's problem because there are tricky entity names around. Okay? Similarly, imagine somebody talking about the movie called The. Now there is a movie name. Now, how do you even figure out that they're talking about that movie? I mean, it's so difficult to figure out that there is a movie name based on whatever is written automatically. Right? So these tricky entity names cause a lot of issues when you want to do automated stuff on top of these, on top of this text. Okay. So that said, are there any questions so far? Any questions? Any discussions? No. If not, then we'll get to some little serious stuff. Okay? So most of these steps you have to do for all such applications. And then, of course, you have to build rules on top of your specific application. Okay? So that's the thing. Okay? So we'll go one by one. So we'll start with tokenization. Okay? So as simple a task as figuring out words in a paragraph. Okay? You are given a paragraph, give me all the words in the paragraph. Now it's a very simple task for humans, right? And just look at various words, and I mean, or even automatically, if I ask you to write code, you will basically try to figure out wherever there is a space and tokenize it, right? But as I mentioned, these apostrophes and these hyphens are the big issue. For example, Finland's capital. Now, if I ask you how many words are there, you will probably say Finland. You can write it like Finland's capital and so on. This apostrophe is not a big problem, but these apostrophes are a problem. So what are is two words, not one word. So similarly, I am, isn't, is not, right? These are all two words rather than a single word. So when you have apostrophes, you need to be careful. You need to figure out whether this is a two-word apostrophe, or automatically figure out that I would or I am, all of them expand to two words rather than a single word. Now with the hyphens, there are multiple issues. Like many times these hyphens are used to combine two words which never go separately. They must go together. Hewlett-Packard. Okay? Now you cannot get rid of that hyphen and then just write Hewlett space Packard. So essentially they are not two words. It's just one single word. Okay? But many times it's okay to remove the hyphen, like state of the art, right? State of the art, even if you store that as 4 different tokens or consider 4 different words, it's completely okay. And many times these hyphens just happen to exist because of formatting issues. Like at the end of a line or at the end of a page, these hyphens exist and you must remove them so as to get the entire word. Okay? So that's that. Now the last case is when the spaces are also ambiguous. So in a sense, lowercase is in general a single word. But many times there are these compound words which you want to split and store as lower space case. So there's not just one word, there are actually two words in it. Okay? And oftentimes it is important to do so. So for example, you are analyzing tweets about demonetization. Okay? And you want to figure out public sentiment about demonetization in Hyderabad. Okay? How would you do that? So any ideas if you want to figure out public sentiment about demonetization in Hyderabad? Yeah, survey is a way where you can take 100 forms, right, and go to Gachibowli, stand there, ask them, and I'll take one form here. I don't want to get all the forms filled here because you guys represent a specific type of population, right? If you have to do a survey, it must be random survey. So it must be done on road, on places like this, in hospitals, in offices, in wherever, right? So that's one way of doing it. What is the other way? From Twitter. Yeah, we'll come back to that. Adjectives. So where do you get the data to analyze adjectives? That's right. So basically, sentiment is carried in adjectives mostly. That's right. But the data you can get from social media, right? So you can basically look at all tweets originating from Hyderabad, right? And it's not very difficult to do that because users put their location on Twitter profiles or they have GPS enabled mobile through which they tweet and so on. There are all the tweets which originate from Hyderabad and have demonetization in it. Okay? So now some of the tweets can contain #hate Modi. Okay? So now and of course that's and demonetization also in it, right? So now if it basically says #hate Modi, it's a single word, hate Modi. Okay? Now hate Modi is not a word in your dictionary. You don't know if it's positive or negative. But of course, if you can break that word, hate and Modi separately, you can figure out, oh man, this guy does not like demonetization. It's a negative sentiment tweet. Okay? So basically, it is for these reasons that you need to really split these compound words many times. Okay? Hashtags or otherwise such compound words. You can't just store them as a single word and just be okay doing various NLP tasks. Okay? You have to split them so as to be able to get those basic words and then make NLP sense out of it. Okay? So that's that. So similarly, there are words like San Francisco, where there is a space, but really you don't want a space, right? I mean, you don't want to store San separately and Francisco separately. They don't mean anything without each other, right? So they have to be as a single token in that sense. Right? And lastly, there are these acronyms. So miles per hour, PhD, where you might want to store only the acronym part, but for some applications, you might also want the full form of it. Especially for sentiment analysis, you have a lot of slang which is written in acronyms form. You might want to expand and then get the sentiment carrying words out of it. Okay. So in English, things are reasonably easy. Spaces usually work nicely. Okay? And we know that we have to deal with hyphens and apostrophes somewhat. Okay? But in other languages, life becomes more difficult. For example, in German, noun compounds are often written together. So German noun compounds are not segmented. So for example, if one has to write life insurance company employee, the way it is written in German is this big string without any spaces. Okay? So but if you have to support any kind of application, any NLP application on top of it, you must get these four things separately out of that word, right? Out of that long thing. So therefore, in such languages, compound splitter is a real must. So you really need to figure out how to really divide this particular long thing into 4 different chunks. So far life is good, but it becomes difficult with other languages. Okay? So like Chinese and Japanese. Okay? So in Chinese, there are no spaces at all. Okay? So people don't write spaces. Okay? So basically, a Chinese paragraph would look something like that. Okay? There are no spaces at all unless there's a comma or a semicolon or something of that sort, after which you will find a space somewhere after the full stops and so on or comma. But otherwise, there is no space at all. So now, our first task, I mean, the first thing that one has to do, the smallest thing that one has to do any NLP is to get words, right? How do I get words in such a situation is a problem. Okay? And the interesting part is Japanese is even more complicated, where of course there are no spaces at all, and there could also be multiple variants of Japanese in the same sentence. So imagine writing Hindi, a Hindi sentence which consists of some part in Bhojpuri, some part in Rajasthani or Marwadi and so on. Okay, so basically, it's like a combination of various dialects or various variants of the language in the same sentence. Okay? So without spaces, and that makes it even more difficult to get words out of such things. Okay? So now, imagine you have this problem. So essentially, you have this kind of sentence, which actually should be written like that. It actually should have been written with spaces like that, so that, and then it means Sharapova knowledge in US Southeastern Florida. Okay? But what you have is a sentence at the top. This is the thing that you have. So what do you do? I mean, if you were given this task of figuring out words, how would you figure out words? Well, you have a dictionary, so for example, which lists all the words in the language. Right. So for example, you have this, right? And let's say in English, because you know English, right? So what would you do? You have this kind of thing and you go to the dictionary. T would be there in the dictionary, by the way. But yeah, but THE, okay, and then do what? Right, but then there is no search. I mean, essentially, say you have, as I mentioned, tweets basically, right? And you have hashtags and you want to break them, right? So there is no search at all. So somebody has written in his tweet, demonetization is killing me. Okay, #hate Modi. Okay, now what do you do with the? I mean, there's no search there, right? So basically, and in general, so what you try to do was to start from the beginning. In general, oftentimes what makes sense is max match segmentation, in the sense that you start with the entire thing first. Okay? It doesn't exist in the dictionary, so you remove the last T, okay? And then you search for the entire thing. It doesn't make sense. You remove the last A, and then you're left with whatever you are left with, right? And then you search until you get a word. So the largest sized word that starts with T and is there in the dictionary. What do you want to figure out? Okay? And then say if you have figured out THE, then you move your pointer or you go to C, okay? Or basically whatever is left is what you do the same thing with again. Okay? You start doing that again with the remaining part. Okay? So that's called max match segmentation algorithm. Okay? It's a very simple algorithm. You basically just try to figure out the maximum match in the dictionary. Okay? So this gives you this thing. Okay? But it turns out it may not always work. So for example, the table, this thing, right? I mean, what would you want to read out of it? The table down there. So that's one possibility, right? But if you do the max match segmentation, right? I mean, of course, if you do what he said, I mean, you start with the smallest one, you will probably get that, right? But the smallest one will also have its own issues. Okay? So I'm showing an issue with the largest one. Okay? So then, what would happen if you start with the max match segmentation kind of thing? Anyone? Huh? The tab is a word? I don't know. Theta is a word. The tab, I don't know if there's a word. Okay? So this is what happens. Okay? So now, I mean, you get something, but it doesn't make much sense. Okay? So now the question is this: now what do? You have two things, right? And which are syntactically correct splits of the original word. Okay? What do? How do you choose the right one? Yeah, it could be based on the context. So for example, if a lot of tweets were also referring to Modi somewhere here and there, you would basically say, okay, #hate Modi. Basically, if you're splitting it into hate and Modi, that sounds more correct because it is talking about, I mean, the tweet has Modi somewhere or the user has used Modi in some previous tweet and so on. So another way of doing the same thing is something called as n-gram model. Okay, so let's not go by what it is called, but let's go by how it is used. So what you do is to really take like a in a offline setup or in a somewhere in the background, you take last 1 year Times of India corpus. Okay. So in NLP literature, corpus is a set of documents. So last 1 year's Times of India articles. Okay. And then you figure out how many times a phrase occurs as is. Right? For example, Narendra Modi will occur many times. Okay? But Narendra Mittal may not occur many times. Okay, I'm sorry if one of you is Narendra Mittal, but yeah, I just made up some name. Okay, so basically saying certain two-word combinations are going to be much more frequent. Okay, but most of the two-word combinations are not frequent. Okay, so for example, here the table down there are going to be much more frequent than theta bled on there. Okay. So, and that tells you that the probability or the possibility of seeing this in usual English is much more than probability of seeing this stuff. Okay? So based on this probability computations, you can basically choose the best one out of various possibilities. Yeah. I mean, you can, so I mentioned 1 year of Times of India articles, but you could essentially crawl or by crawl, I mean, just download n number of web pages, English web pages. Oh, there is usually not a tie. I mean, yeah, if there is a tie, then basically you can't do much. I mean, if there is a tie, it basically means both are equally probable. So there is nothing much that you can do. Unless you have some context. If you have some context, you can resolve it based on the context. If you have a tie, you randomly choose, that's all. Then you can't do anything. And if you can't do anything, you can't do anything. So if you have a context, sure, you can break the tie using the context. You can choose the first one. Yeah, randomly choose one, or you can choose first one, it's also random. It's not. I mean, usually nobody calls a crawler as an NLP tool. Crawler is a crawler. Yeah, but I mean, it doesn't give any insights. It basically just downloads the pages, right? So that's just like a software. It doesn't give any insight out of what it's called. You could, okay, so how do you come up with two options? That's a very nice question. Okay? So basically, to come up with multiple options, what you do is to search for all possible words that start with T and fit here. So it could be the, it could be theta, it could be whatever. And then say you have two words which start with T, right? The and theta. So then you expand more on that. So after that, what are the words that are possible? So you come up with all possible things. Right? So rather than using min or the match that I was talking about, you use all, right? And then come up with all combinations. Okay, so this doesn't work nicely in English, but of course you can, as I mentioned, you can use probabilities learned from a large collection of documents to be able to figure out which one is correct. It doesn't work in English just by itself. But interestingly, the way people write Chinese, they have evolved such that there are no prefixes. The Chinese is a prefix-free language, which basically are reasonably prefix-free. What does that mean? That basically means that one word is not a prefix of the other word. So everyone understands prefix. What is a prefix? So so for example, the is a prefix of theta. In a sense, if a word starts with another word, it's basically called a prefix. Yeah? So in Chinese, it turns out that there are not many prefixes, which basically makes sure that this kind of algorithm, a simple algorithm as that, works reasonably well for tokenizing Chinese sentences. Okay. So that's that. So now the next step. So essentially, we have done tokenization. Nice. We have gotten the words. Okay? But many times words exist in various forms. Okay? So for example, USA is the same as U dot S dot A dot is the same as America is the same as United States of America. All of those mean the same thing essentially. Okay? So normalization is the process of normalizing terms. Okay? So basically for information retrieval or even for search engines, right? If you're searching for USA, right? You also want a page which basically has U dot S dot A dot, right? It contains what you are looking for. Okay? So therefore, you must take care of doing those kind of things. So essentially, if somebody is searching for USA, it should just be able to match U dot S dot A dot. Okay? Then we implicitly define, so basically to solve that problem, what we can do is just delete whatever periods or whatever these dots we see. So as an alternative, sometimes what we also need to do is to do asymmetric expansion. Okay, so before going into that, what happens is if somebody is searching for U dot S dot A dot, still they should be shown a page with USA. So the both ways it is equivalent. If somebody says USA, it means U dot S dot A dot also, and if somebody says U dot S dot A dot, it also means USA. Okay? But not for everything. Okay? For certain things, this relationship is asymmetric. Okay? What does that mean? So let's take an example. If somebody is searching for window, just window. So it's okay to show window as well as windows. Okay? Somebody is searching for windows, then it's okay to show, of course, the Microsoft Windows and somebody to fix windows or buy new windows for a house and so on. Okay? But if somebody is searching for capital Windows, it's really, really bad to show a web page which the furniture windows. Okay? Because if somebody has written a capital W, they mean Microsoft Windows there. Okay? So therefore, certain expansions or certain alternative expressions hold one way but not the other way around. So they are asymmetric in nature. So therefore, when you're doing normalization, you must make sure that you are doing it in a nice way. So that's that. The next part is case folding. So many times, so when you are doing this text processing, right, people will tell you that, well, lowercase everything because cases cause an issue. So many times, you don't want to really make any difference based on the case. Okay? So, which helps in making sure that you can sort of correlate things that mean the same thing. Okay? Since users tend to use lowercase. So if you are searching for something, say for example, you're searching for International Institute of Technology, Hyderabad. First of all, nobody writes that big thing. They will probably type only IIIT Hyderabad. But even if they type International Institute of Technology, they are not going to type I capital, and then T capital, and so on. So most of the times, queries are all in small letters, small characters. Okay? So therefore, many times what people do, as a rule of thumb, whenever some text comes to you, you usually lowercase everything. But that fails in certain cases. So in some cases, if you are searching, so when do you write capital letters in your queries? Have you ever written capital letters in your queries? When do you write capital letters? Yeah, when you are searching for some error, right, in your code or some error message, right, you basically copy paste stuff and then you have capital letters. But in general, when you have typed queries, have you used capital letters? manually typed queries. Have you ever used capital letters in your query? No. Have you searched for acronyms? So, for example, essentially, say if you are searching for General Motors, okay, just try searching for without any capital letters. Now, General Motors can mean anything, right? But General Motors with capital G and capital M means a company. Similarly, if you are searching for SAIL, Steel Authority of India Limited, right? I mean, if you so there are certain cases when you are dealing with them. There are certain cases which you should not lowercase. So if all the characters in the word are in uppercase, it could mean an acronym, and if you lowercase, it could mean completely different, right? SAIL, Steel Authority of India Limited versus sailing a ship, right? So it could mean completely different things if you just lowercase things. So when you do case folding or lowercasing things, it's important for certain applications, but you should be cautious when doing that, is the point. Okay? So in fact, for certain cases like sentiment analysis or machine translation, case is actually very important. So for example, US versus us. If you just lowercase things, the USA will not remain USA, it will become us. That's the thing. So the next interesting, so these are all tools that you sort of need to know if you build any natural language processing system, because they help simplify your text. They help simplify and help you understand or extract meaning out of your text. Okay? So this one is called lemmatization. So has anyone done lemmatization? Knows what is lemmatization? Okay. So in language, there are so many interesting things, right? So consider any particular word, right? Say run. So there are various reasons why you transform this word. So for example, you make it running, you make it ran, right? And why do you do that? So why do you transform words from their base form? Tense, basically, right? To reflect the tense is why you basically modify them. To make it a gerund or a verb, right? You modify things, right? To make it plural, you modify things. Cat to cats, dog to dogs, right? Why? What are the other reasons why you modify words? Good, better, best, weak, weaker, right? And so on. So basically for degree or intensity, you modify words. What else? For making the antonym, right? So important, unimportant, you modify the word. So you modify words for a variety of reasons, right? So for example, authority can be modified as, not authority, but authorize, authorization, authorized, authorizing. Now all of them are forms of the same word. Now, when you are doing search, right, say if you search for something like the form to authorize my wife as whatever, okay? So now, if there exists some document which says authorization form, do you want it to match or not? Of course, you want to match in the sense that if you're searching for some authorization thing, you do want to match that authorizing with authorization. Okay? So therefore, many times it makes sense to lemmatize things and to bring them to their base form. So lemmatization is the process of removing these inflections or variant forms, okay, to the base form. So for example, this is what a lemmatizer would do. So it is like a piece of code which will take various words and then get to their root form. So for example, the boy scarf with different colors will become something of that kind. But interestingly, one nice thing about lemmatization, it always tries to find the dictionary word. So in the sense, it will basically convert cars to car and so on. Whatever it does, the final word should be present in a dictionary. So that's the nice part about a lemmatizer. So now lemmatizer is good on search. So for example, for search-based applications, it is very important to have a lemmatizer so that things that should match will match because they have a matching base form. Okay? But in some cases, it is bad to use lemmatizer. For example, for cases where these where these changes, or basically where these inflections, as they are called, are important. So for example, while doing machine translation, so in Spanish, the word quiero means I want, quieres means you want, querer means want. So if you lemmatize them, they will all become queer, and then they will lose their inflectional meaning. So they will basically, this particular variation happens because you want it to say I want. So therefore, if you do lemmatization when you are doing machine translation, that's bad. But if you are doing lemmatization while you are doing, say, matching or web search or any search in your large collection of documents, it's good. Okay? Make sense? So that's called lemmatization. Okay? So the next one is stemming. Now stemming is very similar to lemmatization, but stemming is actually very crude. In the sense, it basically just takes a word and then chops off the last few things. So for example, if I asked you to lematize things, what would you do? You would basically take running and then remove ing for most of the things. The simple rule is remove ing from the end and you will get the base form of a word. It's a very simple rule. As you mentioned, ed, right? Remove that ed from the end and you will get the base word. Okay? So for example, automates, automatic, automation will all reduce to automat. So it's basically just going to chop off last few. Okay? So this thing would become that if you sort of run a stemmer on top of it. Okay? So the nice part is that you do want to do stemming for large words so that things can match, so that your query can actually match to a relevant document. Okay? But then the problem here with stemming is that you may not always end up with a word which exists in the dictionary. So that is a little bit of a problem, because you cannot really then give out the stemmer output to users. If you want to build a system which uses a stemmer, you want to sort of output things by reverse mapping them. Okay? So basically saying in a lemmatizer, it's good in the sense that the output is human readable, because all the words exist in a dictionary, but not in case of a stemmer. Okay, so now how would you do stemming in general? I mean, any kind of interesting rules that you can sort of talk about to do stemming? So we already talked about ed, removing ed, right? What else can you do? Any other rules? Yeah, so basically you can remove er and then make weaker to weak and so on. So there's a guy called Porter, okay? He's a linguist, and what he did was to come up with a set of those rules to do these things. And then that algorithm is called as Porter's algorithm or Porter's stemmer, a very popular stemming algorithm. In fact, the most popular stemmer for English. Okay? So what it does is to come up with rules of this form. So it applies those rules one by one. So like caresses will become cares, cats will become cat, so on. And then, he suggested that let's not remove ing every time it occurs. Okay? Because then thing will become k. Okay? And that's not what you want to do. Okay? So therefore, what he said was to really remove ing only when there is a vowel in the remaining part of the word. Okay? And that was a very good observation. So I don't know if you have observed this thing, that usually ing is added for words which have a vowel in them. Okay? So that's that. And then there are other kinds of rules that he proposed. So basically like relational to relate and revival to revive and so on. So there are a series of these rules which are usually used to do stemming, and then whatever is left is basically called the stem of the word. Okay? So now, I mean, you would ask that why did he propose stripping out ing only when there is a vowel and so on? So what he did was to do an experiment. Of course, this is what is expected. Walking should become walk, but sing should not become s. It should remain sing. So he did an experiment. So he took Shakespeare's plays. Right? So there are like around 30-35 Shakespeare's plays. He took all of them and then figured out all words that end in ing. And then he sorted them in a descending order. So in the sense, figured out top 10 words that end in ing. He looked at them and then he said that, well, so ignore that text, that's Linux script to figure that out. But anyway, if you look at words, top 10 words which end in ing, right, he saw that if I remove ing, only 2 of them make some sense. If I remove, can help me get to the root form. So being to be, and coming to com. Now come, but it's okay to even say com as a stem form. Okay? So therefore, then he tried all sort of combinations, and then he said that, well, let me really look at only those which basically end in ing as well as have a vowel in the remaining part, and then sort them in descending order. And then he realized that, well, 7 out of 10 actually makes sense when I actually remove ing. Okay? And that is how he came up with this rule. And that's how, he has designed all of those rules which basically help us get to the root form of the word. Okay. So stemmers are good, but they have their own issues. So in the sense that stemming is not really context sensitive. So for example, if I was, imagine a scenario where I was searching for Microsoft stock price, okay? And the web search engine is using stemming, so it will stem stocks, Microsoft stocks price or Microsoft stock price, right? So it has stock. And let's imagine there is a web page on Flipkart, right, which is selling stockings. So now, interestingly, what this guy is going to do, what the stemmer is to really convert stockings to stock. And then it will match. Okay? It will basically say, oh, it talks about stock. Okay? And that is a really, really bad match. Right? like I'm looking for stock's price and it matches some stock, but it's not the stock that I want, and it's like stalking. So those are issues that can happen if you're doing stemming. So in a context insensitive way. So it's basically not able to take the context and then act accordingly. Well, Lemmatizer does that. So Lemmatizer, Lemmatizer, what it does is to really look at the context. So Lemmatizer tries to look at the context, tries to understand why a particular variation occurs. So, for example, consider a case about say somebody is using the word saw, right? So, if the word is used in the verb form, the Lemmatizer will try to really figure out, oh, it is the verb form, therefore it should lemmatize to see. Okay? But if it is used in the noun form, the Lemmatizer would really really keep it as saw only. It will not really lemmatize and reduce it to any short form. But a stemmer would really just use the rule, remove the W or AW at the end, and then just always return an S. So that's how stemmer is more or less a dumb algorithm. It's useful for longer words. But Lemmatizer is much more intelligent, but then it is also more complicated to write, because Lemmatizer has to really depend on context analysis. It has to look at the context. It has to figure out what is the tense or what is the part of speech in which the particular word is used, and so on. This is basically a demo hosted by Stanford University, and then you can type in whatever you like. So, can you suggest some sentences? So I can type in, I am teaching at Avasa in Gachibowli, 3:33 p.m. on 19th November 2016. Right now, okay, we are in, so maybe you can do some more thing, some more interesting thing. Okay, let me just put it as, so what do I put it in? We are in a hotel, in Hyderabad, of course it is not USA, but I just want to tell you, one of the things, and that is why I basically do that. So let's see what happens. So what this guy does is to really take that stuff and do a lot of natural language processing, as we talked about. Okay, some of the things we have talked about, some of the things we will talk about. So hopefully it will load some things soon. Yeah, still waiting, loading. Oh, I see. There's a lot of things going on this machine. Okay, yeah. Yeah, so for folks who are doing it on their own machines, they can actually see some result, right? And it's a very nice result. So if it comes up in 1 minute, it's good. Otherwise, I also have a slide. So where I have like copy pasted stuff, because at various places internet connection is a problem. Okay, since it didn't come up, I hope it will come up after we discuss the slide anyway. Okay. So here I tried something else. Now the only point is there a way for me to enlarge this thing? Ouch. There's no way to enlarge this stuff. So this was the original sentence. Where is the original sentence that we gave to it? This is the thing that we gave to it. Okay, I mean, let's not go to a real sentence because that's in large font. Okay. So this is what it does. So basically what it is going to do is to really figure out that there are 3 sentences in it first. So it does sentence segmentation. And then besides doing sentence segmentation, it also does tokenization. So it is going to figure out what are the words in it. So here I did not have any I am, I or I would kind of word, but if you put in that, it will also tokenize and figure out that there are multiple words of that kind. And then for each of those words, it also gives you a part of speech. So for example, here it is marked my name as a noun. And NLP is a noun, a proper noun, right? And then is a verb, teaching is another verb, VBG is the verb gerund, and so on. So essentially, at is the preposition, IN is the code for preposition, Avasa is a noun, and so on. So this is the first thing it does. So part of speech tagging. Let's hope. This is just it has given up. In fact, okay. So besides part of speech tagging, it also does named entity recognition. So what is meant by that? So essentially, it figured out that my name is a proper noun, but it also figured out that it is a person name. And then it figured out Avasa is a location, And then it also figured out that Hyderabad is a location. It also figured out 6:30 p.m. is a time. And 19th June. So that was an old example. So that's why we have 19th June. But anyway, that's a date. Okay? So it can figure out those things automatically. So imagine if you are given, say, you're working in a company and somebody asks you to really take the entire wiki take the entire wiki or all the collections of the company, and somebody tells you, get me all the names of the projects mentioned in these documents. So if you want to figure out all projects that have run in the company so far, this is a very nice application. Essentially, you can run such a tool to figure out project entities, okay? And then label them like that. So that's one. So then the other thing that this demo does is to really come up with this stuff called as co-reference resolution. Okay? So remember when I provided an example of co-reference resolution, what was the example? Carter told Mubarak that he shouldn't run again, right? So what does he refer to? Okay? The same thing is here. Essentially, when I have mentioned it basically figures out that it really means Avasa. Okay? So teaching at Avasa, and then Avasa is in Hyderabad. So basically that's the other thing it does, co-reference resolution. And then the last thing it also does is to figure out these basic dependencies. So now, which is a real lot interesting stuff. Okay? So here, these dependencies basically help you solve problems like subject, verb, object identification. Remember in schools, that is also another thing that you used to do. So it tries to figure out that teaching is the verb. Okay? And then N sub J dependency. So there are these dependencies are basically pairwise dependencies between words. So this N sub J dependency is basically going to tell you that this particular verb relates to this noun. So basically Gupta is the noun here. And then, of course, the compound dependency tells you that this word is not by itself. It basically is with the other word. Okay? And then there's another dependency which basically tells you that this is the object. So at Avasa. Okay? And so on. So essentially all these pairwise dependencies sort of tell you various aspects, various syntactic aspects that one can discover from a sentence, from an English sentence. Okay, so that was the demo part. Now let's see. Okay, this thing also has come up. In fact, is there anything interesting I can show? Yeah, the interesting part that I can show here is as follows. So which was not there on the slides. Right, so the interesting part is here the u.s.a. So it did not really, so the nice part is it still figured out that there are three sentences, right? If the sentence splitting was done just based on the dot, it would have created many sentences, right? So, but it figured out that u.s.a is a part of a single sentence. Okay, that's that. And then what else? So basically, NER failed for some reason. Yeah, usually it does not fail. Mostly it is because of the internet connectivity or whatever. Others also failed because of internet connectivity problem. Anyway, okay. Yeah. I mean, there is nothing else nice to show here just because things failed reasonably. Anyway, so if you go back at home, you can just try Stanford Core NLP demo and you will get that. And then, the description of all of these. So there are these tags. Now, what are these tags? What do they stand for? You can really search for pen, tree bank, part of speech tags, and you will get their meaning. So basically, PRP is a pronoun, VVP is some word. So verb, past participle or something of that sort. I don't know exactly what. But it's a particular kind of a verb and so on. Okay? So just search for pen tree bank. Pen is PNN. Pen tree bank. Yeah, I can search here, but I'm not sure if it will work. Yeah, Control T is itself not working. Oh, it's working. Okay, pen tree bank. Yeah. Let's give up. But basically, now the problem is about. For sentiment analysis, there is no state package. I mean, well, there are tools. So there is a package called TM, so text mining package, which allows you to do all of those things that we talked today. Lemmatization, stemming, case folding, all of these can be done using text mining package. Sentiment analysis, you will have to build your own. Usually, there are some softwares for sentiment analysis, but there's nothing like a package in R to do that. Okay, so let us talk about the sentence. Yeah, go ahead. Yeah, that's a good question again. So now you are asking interesting questions. So basically, that's called as named entity recognition. Remember one of the tasks that we talked about in the beginning? So we talked about Einstein met the UN officials in something, right? So list-based approach or list lookup approach is one thing where you have a dictionary of all names, and then maybe the name matches in the dictionary, and that is why I put that as a person name. But there are more approaches beyond that. So for example, if something is teaching, then that something must be a person. So by looking at the context words, I can try to figure out, oh, this is a person. Yeah, so maybe it has in dictionary my name, who knows? I mean, but anyway, yeah. So, but did you put that with capital, the first word? Okay. Yeah, so sometimes it works, not always it works, but most of the times it does work. So, maybe the name that you put in is not very common. So try putting in some common name. So in the sense, something that can exist in a dictionary. So, but anyway, so there are more approaches than beyond dictionary lookup. So many times it just takes words based on the context and tries to guess what is the thing. So what does it guess that thing as? So is there an entity that is marked at all? No entity is marked at all. So most of the times it works, sometimes it doesn't. Anyway, so now let's come to sentence segmentation. Sentence segmentation in general is a very simple task. Basically, you have, so the task is you are given a paragraph, you want to figure out sentences. How would you do that? You have a paragraph, you want sentences out of it. What would you do? Full stops, right? You look for full stops. Well, you also look for exclamation marks and question marks, right? And exclamation marks and question marks are reasonably easy, right? They are unambiguous, but full stops are not always full stops, okay? So period is quite ambiguous. Sometimes it could be sentence boundary, and most of the time it is a sentence boundary, but sometimes it could be a part of an abbreviation like Dr., INC, and so on, okay? And sometimes it could also be a part of a number. Or it could be a part of that acronym, right? U dot S dot A dot. So not always do you want to really consider a full stop or a dot as a full stop. Right? So therefore, what you want to do is to build a binary classifier. How many of you know what is a classifier? Yeah. So then in that case, what you do is to a classifier is basically a machine learning model. So basically saying you try to make some sort of rules into that model. So in the sense. What could be good rules to figure out if a particular dot is a full stop or not? Yeah, I mean the next word must be capital, must be starting with a capital letter. This particular word should not be starting with a capital letter. There should not be space. Yes, exactly. So if there is a number, then there will not be a space in general after the full stop. If there are new lines after the full stop, then it is like end of paragraph, which basically means it's also end of sentence and so on. So these are all various rules that you can encode in a binary classifier. Yeah, but the classifier is nothing but a some sort of model based on these handwritten rules. There are all these rules: case of the word with or after the dot, length of the word with the dot. So if the word is like dr dot, right? So usually abbreviations are shorter. And so on. So you can all encode all of those rules and then build a nice sentence segmenter. Okay. Okay. So the next task, and I don't know what is the time. So this is the time we will end at some point. So 3:48. Okay. So there's still some time. Okay. The next task is like phrase identification. So what is a phrase in general? Anyone can sort of define what is a phrase? Combination of words, but is every combination? Which makes some meaning, exactly. So combination of words which makes meaning beyond those particular words by themselves, right? For example, blood test is a phrase because blood and test have meaning, but when combined, it is a specific thing, right? So a concept is what you can call a phrase in some sense, right? So how would you find phrases? So basically, if I give you like a paragraph and I ask you, give me all phrases in this paragraph, how would you do that? Any ideas how would you find phrases in a paragraph? You must have a list of phrases. That's of course, if you have a list of phrases, you can do exact matches and then figure them out, right? So that's one way of doing it. But I mean that's very difficult to build a list of phrases, right? Yeah, so we can basically start with one word and then say, oh, does the next word go with this word or not, right? So for example, one of the examples about blood test is that, after blood, whatever is the word, try to figure out, say based on, again, last 1 year of, say, Times of India corpus or correctional documents, try to figure out whenever blood was mentioned, how many times it was followed by test. If a large number of times blood and test occur together versus they occur individually, then it means that these two go together a lot of times, right? And in that case, you would put blood and test together, and then you go for a third word. Maybe the third word does not occur too many times with the blood test, and then therefore you ignore and then say, oh, my phrase ends there. Okay? So that's one way. Okay? And that's basically the third way, one of the ways that I have not mentioned here, but it is mostly about using something called as mutual information. So mutual information between two words. So the two words co-occur a lot together, they are called mutually co-occurring words. Okay? And there are other two approaches called as runs of words approach and sentence parsing approach. So what is the runs of words approach? The runs of words approach is very simple for phrasing. What do? You consider all runs of words between stop words. So English has some words which are called stop words. What are stop words? Anyone knows what are stop words? Stop words? No? So stop words are words which are sort of filler words. So like the, a, and, on, all those prepositions are all called stop words. Okay? So this particular approach is very simple. Consider all runs of words between stop words. In the sense, just like for tokenization, you were using spaces as delimiters. Here, for phrasing, you would use these stop words as delimiters. Okay? So, for example, the previous slide, if I were to run a phrasing approach on top of it, this is what happens. So, is, to, as, makes, more, they are all stop words because they occur too many times in English, right? And anything that is separated by them is like a phrase. So, for example, indexing units is a good phrase, blood feather, blood test, bloodhound, adjacent words, index element, they are all good phrases. Okay? Of course, you need to post-process this part, so in the sense, after you get these phrases, you can remove those which are just length 1. So, like index, if also marked as a phrase, but you can remove that, saying phrase should have at least 2 words. So this is a very simple and a very, very easy approach for phrasing. So, and all it requires is a dictionary of these stop words. So, and dictionary of stop words is very easy to get. I mean, take again last 1 year of Times of India corpus, right? And then figure out words that occur a lot of times. So, like every article will contain a and the too many times, and therefore those are basically stop words. So if you apply stop words on some large corpuses, right, on some large data sets, then this is what you get. So these are all interesting phrases if you look at, and in fact they contain a lot of locations which are two-word locations. So remember that New York example which was screwed up because you were using space as a delimiter. Now if you have done nice phrasing, you would know that New York is a single thing; it goes together, and therefore you will not split it using a space. But keep it as a single indexing unit. Okay? So most of them make sense. There could be a few things which don't. So for example, example 1, table 1, they come up just because they're taken from US patents corpus. Right? But most of them actually make some reasonable sense. Okay? Now the other way to do phrasing is to really use syntax or this kind of constituency parse tree. Okay? So remember on the very first slide when I was talking about various NLP tasks, I told you that you can also build a constituency parse tree or a syntax tree, right? English syntax tree. So for example, here the sentence is a dog bit the boy on the porch. Right? So now for this sentence, of course, you can do first level parsing and then figure out, oh, they are these part of speech tags, article, noun, pronoun, and so on. And the second level, you can combine these to come up with phrases. Okay? So, for example, the porch combines together to form a noun phrase. Okay? And then on the porch combine together to form a prepositional phrase, and so on. Okay? So, you can combine all of those, and that is how you can come up with this tree called as the constituency parse tree. Okay? So now, and of course, there are softwares to do this. So, essentially, the same software that I showed you online, the Stanford Core NLP software, you can actually download it, and you can run it on your sentences, and also come up with trees of this kind. So the nice part is that once you have these trees, what you can do is to really look at these phrase nodes. Okay? So NP is a noun phrase, PP is a prepositional phrase, and then VP is a verb phrase, and so on. So you can just look at all the noun phrases, and then and then whatever are the words which correspond to that noun phrase can be called as a phrase. So for example, the porch is a phrase as per this particular parse tree. Now, of course, not all of them are reasonable phrases. Like the porch is not really something like a useful phrase, right? So therefore, what you could do is to really apply that mutual information thing on top of it. Does porch always come with the, or does the always come with Porsche only? No, right? I mean, the usually comes with many of them, and therefore clean up this one and say, oh, this doesn't look like a phrase. But all the candidate phrases you can get by really looking at these NP, PP, or VP names. Okay? That's another way of doing doing phrase detection. Okay, so yeah, we have looked at a variety of these tasks. So we started off with what is NLP, then we talked about what is sentence. I mean, how do you really take text and start processing it, right? So basically, find sentences from it, find phrases, find words from it, and then stem them or process them such that normalize them or lowercase them and so on. So since we have some more time, we will also look at word sense disambiguation. Okay? And this is actually going to be pretty interesting. So remember the example. So I want new batteries for my mouse, and the point is that you want to figure out which mouse. Okay? So how do you do that? So any ideas? How would you do that? So of course you have a dictionary, and what does a dictionary contain? A dictionary contains a set of all words, and for each word it contains meaning. Right? So meaning such that it is written in simple English, right? Simpler English than the word, okay? And it has meaning of all the senses of that word. So for example, consider this sentence: I am going to withdraw money from the bank. Okay? So now bank has at least two senses which is popular, right? One is the river bank. So everyone knows river bank, and the other is the finance institution, right? ICICI Bank. Okay. Huh? Yeah, these days people know only one bank, right? So yeah, I mean, in the sense that yeah, so this sentence I've been like talking for like 4 years, and nobody thought of it that way. I mean, that withdrawing money from a bank is such an important thing. But anyway, so in the recent situation, everybody knows only one bank. But anyway, the point is, coming back to the example, what we want to do is to really go back to the dictionary, look at the dictionary. It says bank has two meanings. One is the river bank, the other is the institution, financial institution bank. Okay. So, and we want to figure out what is the sense in which bank is used here. Essentially, figure out which one is the right bank that applies here. Huh? Of course, the financial bank applies here, right? But we want to do it automatically. Okay. How do we do it automatically is the question, right? Yeah, keep the other words in a sentence, the context words, as you said, right? So money, what else? Yeah, withdraw and money, right? We could also draw water, but anyway, so withdraw is probably money related, and money is related to bank. The hope is that money and bank you will be able to make some relationship somewhere. So how would you make that relationship? Probably based on the description in the dictionary. So dictionary usually contains meaning for every sense of a particular word. It also contains sometimes example usages. So example sentences in which this particular sense can be used in. And some dictionaries have antonyms, synonyms. They also have something called as hypernyms and so on. Okay? So using those various kinds of words and comparing with the context, you can sort of say which particular sense is being used in this particular sentence. Okay? So yeah, let's skip this one. So we will talk about 3 approaches to do this stuff, right? And vaguely, which is based on what we just discussed. Okay. So for that, let's look at this example. So there is one example in which serves is used. This airline serves dinner in the evening flight. Okay. And then there is another example. So this airline serves the sector between Agra and Delhi. Okay. So both of the sentences use serves as the as the word, okay? And in both cases the word is a verb. In some cases the particular word is a verb, some cases it is a noun, and so on. It is easy to disambiguate in that case. But in both cases it is a verb, right? But the senses are different, right? So all of us understand here it could be like serves dinner or serves breakfast, meals, lunch, or whatever, right? Or food and so on. But in this case, it serves a sector or serves a region or serves the area and stuff of that sort would be the kind of thing. So therefore, one way of doing this word sense disambiguation is to list down for every verb a set of possible objects for that verb. Okay? Say in the dictionary, you also had set of all possible objects with which this verb goes. Okay? For example, in this case, this serves goes with any kind of foods, in the sense food, breakfast, meals, etc. Right? And this one, this serves goes with the sector or region and a few set of objects, right? So basically saying, if you can exhaustively enumerate the argument structure of the verb, in a sense, all the set of objects that this goes with, then you can use that to really do disambiguation easily. Voice sense disambiguation. So when, if you are now given a sentence like this flight serves a region between Mumbai and Delhi, you would say that, well, region is present in this particular sense of the verb serve, and therefore you would say that this serves is really this particular sense. Okay? So is that understood? So essentially, but the problem is, for this one to work, you will have to come up with a dictionary which gives you a set of objects that go with this particular verb serves, which is not very easy to do. It's basically a very time-consuming thing. You'll have to list down a lot of things. So, but a better thing to do is to really look for context words. So, let's in fact look at this example. On burning coal, we get ash. Okay? And you want to figure out which particular sense of the word of the word ash is being used. So, you want to do word sense disambiguation for the word ash, right? So, you go back to the dictionary and you figure out there are three senses in which the word ash could be used. Okay? In fact, ash is also the name of a tree. The particular type of tree, trees of the olive family with pinnate leaves, thin furrowed bark and grey branches are also called ash trees. Okay? So ash is also the solid residue which is left when you burn stuff. And then the third sense is the verb sense. So to convert something into ash is also called ash. Right? I mean, he ashed the tray or whatever, he ashed the papers and whatever. Basically converting something to ash is also called ash. Yeah, absolutely. Ash can also be a name of an actress. That's pretty right? So in fact, there could be a fourth sense here. It's just that it doesn't exist in the dictionary. That's right? But yeah. It could also be the name of an actor, Aishwarya, right? But anyway, so the whole point is that so whatever it is, right? And as we discussed, this has to do, this goes back to the other kind of problem when we were talking about Gandhi and so on. Okay? The same problem, when we are talking about common words, it's called as word sense disambiguation problem. But if we are talking about proper names, it's called as entity linking problem. Actually, the problem is the same. So you're right. I mean, in fact, usually people don't talk about common words and proper words together. I mean, so for example, usually in entity linking world, people will say Gandhi went to Bangalore and gave that speech. So now there the problem is to figure out which Gandhi. Is it Rahul Gandhi? Is it Rajiv Gandhi? Is it Sonia Gandhi? And so on. But here it's an interesting thing. I mean, if you really see this ash, it could be any of these three or fourth, an actress, and so on. Okay? So the point is that you have to figure out which of those senses is the right sense. Okay? There are three possibilities and you choose which one. Okay? So, and as we discuss, we look at the context. So in the context, what do we see? We see words like burn, burning and coal. So now, if they are very clear, right, and if they are this unique meaning to coal and burning, what we can do is to really figure out which of the sense has a nice overlap with the context. Okay? So basically, we find that this one says burned, right, and this one also is burning. So then, okay, it makes some sense, right? So basically, sense 2 is quite related, while sense 1 and sense 3 do not have anything like burning or anything like coal. Of course, we don't care about these stop words like on, be and get, because they are like filler words, they will match anywhere anyway, right? So we don't care about those words, but we care about important words and so on. So, but then, I mean, what one can, so of course one can just consider this as a context and then match each of them, and then whichever has a good match is the one that wins. Okay? So in this case, sense 2 would win, because burn at least occurs here there is burning. So again, you know, stemming is one thing that helps here. So burning is the same as burned, right? Because when you stem them, both of them become burned. So, but what more can we do? So what we can do is to go back and look for senses of coal. So we go back to the dictionary, we see what all can coal be, okay? And then use it to really create something called as a context bag, in the sense that now our context is not as small as that, but our context is this entire thing plus the words in the same sentence. Okay? So which helps us to have a larger context. So now if we go back and sort of find a match with this context and this sense one, well, still there is not much match. I mean, if you will see, there is not much of the useful words which will match here. Okay? But if you go back, if you look for overlap between this sense 2 and this entire context, you see a lot of match. I mean, this solid which is here, combustible which is here, burn which is here, and so on. Again, if you look at the sense 3, it has hardly any match with the context, right? So basically, whatever matches the context is the one that wins, and in this case, again, sense 2 is the one which will be used, right? Of course, if you have Aishwarya Rai here, then there would be words like Bollywood and stuff which do not match any of burning coal, and that's the reason why that will not match in this particular case. Yeah. Okay. So the last approach for word sense disambiguation is based on, or maybe the second law. So the next one is very simple. So I'll probably just call it second law. This is based on categories. So imagine a dictionary where you not just have words and their meanings, but also categories. So in the sense that bank has two meanings. One is the river bank, and the location from which you can withdraw money and so on. Right? And then with that, you also give a category. So this particular sense is used in the location sense. This particular word bank is used in the location sense, or this word is used in the finance sense, and so on. So imagine that all words are categorized into say 10 broad categories: finance, location, health, sports, and so on. Okay? So in that case, what you could do is to, so for example, now this is a sentence: the money in this bank fetches an interest of 8% per annum. Okay? So then you want to figure out what this bank means. Is it the location bank or is it the finance bank? Of course, it is the finance bank, but we want to figure out automatically. So what we would do is to really go back to the dictionary. Dictionary says there are two senses: one, the location sense, and the finance sense. Okay? So therefore, we have two columns here. And then we look at all the words in the context: money, fetches, interest, any useful words around. Right? And then go back to their dictionary representations. Right? Go back to the dictionary, figure out what all senses money is used in. So it turns out that money votes 1 for finance. Money is never used in the location sense as such. Money might be used for other senses, but of these two, it is used in the finance sense. Similarly, other words are used. Say annum is used in finance sense, interest in finance sense, and so on. So as you see, the context really votes more for the finance sense rather than for the location sense. And that is why, again, in this case, using this kind of categorical dictionary, you can really come up and say that, well, here bank is used in the finance. Okay? Yeah. Dictionary is easy to get. So essentially, all of us have dictionaries at home, right? So typical dictionaries also exist online. So you can basically just download a dictionary, say Webster Merriam dictionary and so on. Connect it with the tool, exactly. Okay? So such dictionaries are available, but these kind of dictionaries where there is also this category mark is not very common. So but this is a good approach if you are using it for a limited domain. If you are using for a small domain, these words are only in that domain, say just in jobs domain or a very restricted domain, then you can actually build such a thing and use it. So last one is a very simple thing. Essentially, say if you have parallel corpora. So what is parallel corpora? So parallel corpora is a text which exists in two languages. So, for example, parliament proceedings are available in various languages, various national languages, right? Of course, it is available in Hindi and English, but it is also available in various, I think, 22 recognized Indian languages. Okay? So, the same sentence is translated by someone in. So, let's talk about just English and Hindi. So, it's in English and also in Hindi. Okay? And say somewhere in the parliament somebody mentioned the money in this bank fetches an interest of 8% per annum. It will also be translated in Hindi. So now the nice part about word senses is that the same sense is never translated into the same word in another language. Okay? So for example, consider two senses of the word bank. Right? In Hindi, for one you will use probably in Hindi also it is called bank. For the other one you will use kinara, right? Nadi kinara. Okay? Right? For people, most of you hopefully understand Hindi, right? But anyway, in another language, you'll basically translate it to a very different word. So if you have parallel corpus, so basically saying that with this sentence, if you also had its Hindi translation, it is very useful and it is very easy to then really figure out which sense is being used in the current context. Okay? So a word having multiple senses in one language will have distinct translations in another language based on the context in which it is used. So translations can therefore be used directly to figure out the right sense. Okay. So let me very quickly end with parsing. So we already talked about parsing, so it's not really a big deal now. So parsing basically consists of two types of parsing. In the sense, you could you could create a parse tree of that form, essentially where a dog bit the boy on the porch, right? This is called as the constituency parse tree. So now you would ask, in which applications such parse trees are useful? Why would you build a parse tree? Any idea? How would you create some interesting application out of it? Any uses of parse trees? Right. But we are talking about a natural language right now. Okay, so that's not really an application. Why would you create a parse tree to transmit data? Traversing across that parse tree. But then what would you do based on that? Yeah, that's a nice one. So any other, we'll talk about that. But any other applications about a parse tree? Why would you want to build a parse tree? So I'm not even asking you how would you build one. So how is a very difficult question to answer, but that's homework if you want to think about it. But what would you do if somebody tells you that, hey, give me any sentence, I'll give you a parse tree? What would you do with that? Can you use that to do anything useful? But part of speech you already have, you already have using part of speech taggers, right? You don't need to build an entire parse tree on top of it. Part of speech is just one level. It could help in sentiment analysis. This is one, right? So we also talked about phrasing, guys, a little while back, right? So it could also help you detect these phrases. What are the various phrases in this sentence? It could also help in sentiment analysis. And how? So the point is, usually a particular sentence can contain multiple sentiments. So for example, somebody would say the movie's plot was awesome, but the cast was not very nice, or another aspect was not very good, right? So the entire sentence does not have one sentiment. It has two sentiments, in fact, right? And towards two different aspects. Now, how do you figure out that there are two parts to the sentence? You can basically just do a parse tree, and then at some point you'll figure out there's a left part, there's a right part. Okay? And then if you do sentiment analysis, you can actually see that the left part has probably a positive sentiment, right part has a negative sentiment. And then you can say, oh, this sentence has two sentiments, and therefore it must contain two aspects, and therefore give different sentiments for each part. So that's where these things are useful. So essentially, say sentiment analysis is one example, but there are many other examples where parse trees could be really useful. So for example, if you are doing summarization and a real abstractive summarization. Okay? So what is an abstractive summarization? You won't copy entire sentences, okay? But you'll basically maybe copy parts of the sentences from here, part of the sentence from there, and so on, and then combine them nicely to form automatically generate sentences. Okay? So how would you do that? You do that by really figuring out, proper units. So basically, you won't really take r.bit, but you would take this as a unit. So because this is a proper verb phrase, and then maybe a verb phrase can be combined with a noun phrase. That's what you know from English language, and that's where parse tree can be useful. So if you are doing abstractive summarization, you need to build a parse tree. Okay, so there are various uses where these things are useful, and then the other one we already talked about, dependency analysis, right? So, if you want to really figure out subject, verb, object kind of thing. So, for example, in this case, put is the verb, and who put the thing? The boy put the thing. Therefore, the boy is the subject, and therefore it has that N subject dependency, noun subject dependency. And what did the boy put? The boy put the tortoise. So, the tortoise is the dominant object. So, the object in the particular sentence. Okay? So, where could this stuff will be useful? So, this could be useful where you want to, say, figure out facts from a news article. So, a fact is nothing but a subject, verb, and object. So, a fact is basically who did what, right? So, and also for things like semantic role labeling. So, there is another thing called a semantic role labeling where you want to figure out who did what in that sense. Right? So, it's very useful for fact extraction from a large corpus. Okay? Say, if somebody gave you, you went to a new country and you are a, sales guy there, or you want to sell something in that country, right? And you want to figure out the political scene there. Okay? So, say you don't know anything about that country. What could you do? So, if you have access to, say, last 1 year newspapers in that country, you can run this tool, automatically figure out facts. Okay? And then figure out, oh, X did that to Y, and so on. And that could be really useful to quickly understand a large set of documents, or summarize a large set of documents. So that's that. So this is just more detailed analysis of dependency structure. So it says dependencies are all binary in nature. So they relate different words. So they exist between two words, and they just describe the relationship between the type of relationship between two words. So essentially, it has a head and a head, or also called as a governor, and a dependent. So all kinds of, so these dependencies are also useful to figure out whether a sentence is written in active voice or passive voice. Okay? So active voice sentences have n subject dependency. Passive voice sentences will have n subject past dependency. So based on that dependency, you can figure out how many sentences are written in active voice, how many in passive voice. Okay? So that's that. So this one we already discussed already. So that is all. So that is pretty much the end of the lecture. So what we discussed today, hopefully now if somebody will ask you, do you know NLP? You can actually say, yes, I know somewhat about NLP, right? So we talked about what is NLP and what sort of tasks fall under this big umbrella. Okay? So we talked specifically about the basic modules that are required to build any big NLP system. So tokenization, normalization, stemming, sentence segmentation, so given a paragraph, figuring out all sentences, phrase identification, versus disambiguation, and a little bit of parsing. Yeah, NLP is a large topic, it's a large area. So essentially, right, I mean, there are many books on NLP. Essentially, the next things that we could straight away discuss after this could be like how to do sentiment analysis, or how to really do named entity recognition, or things like how to do summarization and so on. Okay? So, but for this 2 hour stuff, this is all. Where it is related to analytics. So, if you basically want to, so analytics is in various areas. So, as I discussed, right? I think I can go back to the first slide. So if you want to analyze and figure out how many, what percent of the customer base is liking your product, right? How do you do it? So basically get the tweets and then figure out sentiment analysis on top of them. So that's basically a straight example, right? But now I think this slide will start making more sense. Now just go over those applications that are written there, right? And all of them really use some sort of natural language processing. Okay? So for example, let's look at that. A weird application where probably no one is working here, but operator comments analysis. Okay? So let's say you have basically all the discussions between the pilot and the co-pilot and the ground staff is all recorded, right? And they're all transcribed using speech recognition systems. Now, if a plane goes bad or if anything wrong happens with the flight, right, you can always go back to the recording and then do some sentiment analysis, figure out what was going on that caused the accident, or is there anything human that caused the accident, and so on. So all that analysis can be done based on these things. So if there are, based on these chat logs, you can do a lot of analysis in that sense, in various applications. Social media analytics, we already talked about, sentiment of customer interactions, user profiling in e-commerce and retail. By looking at what kind of queries you are putting in, more things can be personalized for you if you can do natural language processing on top of it and figure out, oh, this guy generally buys more of clothes on my portal rather than more of food articles and so on. What are good tools to start with? Okay, so the first one, right? What if there are spelling mistakes, right? So search engines usually are very good at correcting spelling mistakes. Why? Because they have learned from previous users. Small data set, and then you have some spelling mistakes in it. Sure. I mean, if there are spelling mistakes, and so there are tools which do automatic spell correction. Okay? Because and you can install them on your machine, and they make use of simple things like 2 characters on the typewriter or on the keyboard are more frequently interchanged. So those are the typical spelling mistakes. So the ways in which people make spelling mistakes, right? And then there are also tools which sort of encode how people make spelling mistakes when they spell difficult words like Mississippi or pneumonia and so on. And then they have those mappings internally saved in the model. So you can download them and make use of them in your work. Right? Now to the second question, like what are tools that you should start with for this kind of thing? In R, TM package is good. So just try to use TM package. Read its, everyone knows R, more or less, vaguely. So do you know Vignette command? Vignette. So just look up what is Vignette, Vignette. Yeah, so it basically gives you a help file for TM package. And then there are many examples which are written in that help file. So those examples can help you sort of go over those things. I mean, very nice examples which discuss what all you can do with TM package. Okay, so that's one. The other one is the Stanford Core NLP software that I showed you. The online demo, you can download it as a software and then you can run it on as many documents as you like. Okay? So the demo does not show everything. This software also does sentiment analysis. The software builds parse trees, which we did not talk which we did not see in the demo. I don't know about the Brad part, but this is called Stanford Core NLP. So this is called Stanford Core NLP. When I say usually document, it means a text document. It could be a PDF also, but you'll usually convert it to text before doing any text analysis. I mean, usually text file, TXT file. Okay? So, I mean, it depends on what application you're talking about. So, there are various reasons why people switch context and various applications. So, for example, when writing a news story, I might talk about something and then switch to another topic and then maybe talk about the first topic again and so on. Okay? So, there are things called topic models which try to figure out that the first paragraph was more towards, if it is say a cricket match commentary, right? So some part of commentary can be like a player-specific commentary, like Sachin, and then suddenly in between I start talking about the actual match, and I go back to Sachin, right? So there are topic models which help us try to do those things. They're not very accurate. I would take it. Basically, they're not very accurate, but they do at least some part of the job. Okay? So a similar thing can occur when somebody is querying. So if you have two tasks in your mind, you usually, say for example, you are booking a flight from Hyderabad to Bangalore, right? And between your wife tells you, hey, go book a cylinder for me, gas cylinder, right? What do? You basically you're searching for a flight from Hyderabad to Bangalore, but before you complete that search, you start searching for another thing, right? So those are called as interleaved sessions, where, usually a session is a homogeneous task, but, just because you have too many things in your mind to do at the same time, you interleave in that sense. And there is enough work, there's no published software, but there are research papers on how to really remove this interleaving. So how to figure out, this was one task that I used to doing, this was another task. And then say that, this particular thing that looks interleaved is actually these two sessions. Okay? So there is good work, but there's no software as such there. Okay? Yeah, that's a good question, right? So sarcasm detection, we did not talk about at all. But, and there are no good softwares to do it so far. And it's really very difficult to figure out sarcasm. Okay? Sarcasm, is interesting. There are two ways of doing sarcasm detection. One is context insensitive way, okay, in which case the sentence itself contains a sarcasm. Okay, and the other is a context sensitive way. In a sense, say if you basically, if the lecture was really, really bad, right, and you go out and then one guy says to the other, the lecture was superb, right? And that's so sarcastic in a sense, and that has to do with context because both of them attended the lecture and they felt what they felt, right? And then they understand that it's sarcastic. The third person would think probably it was really superb, right? So that's the thing, right? So there are some approaches towards it. It's still in research. I mean, there are some good papers. There is some. So people have tried to use the Friends TV serial dialogues and figure out sarcastic comments from it, and then try to be able to nicely classify and say, oh, this is sarcastic, this is not, and so on. There is no published software. There is no software which will help you figure out sarcastic sentences. Although sarcasm plays a really huge role when it comes to sentiment analysis. So, usually you do sentiment analysis based on the words contained in the sentence, right? But, this is a very nice sentence from one of the perfumes magazine. So the sentence is, if this is your darling fragrance, then you better wear it only exclusively at home and take the windows shut. Okay? This is such a sarcastic sentence and it contains no negative words that you can say that this is a negative sentiment sentence. Okay? So, sarcasm is really important when you do various NLP tasks, but it's difficult to solve too. There are no good approaches to do it so far. No commercial softwares to do it so far. There are some research papers around. Yeah. So we don't talk about the efficiency aspects, but practically you have to do it. So in the sense, you have to really look at every word, look at frequency and so on. Right, absolutely. So the answer is that yes, you still need to. I mean, I know there has to be stuff done efficiently, but you still need to really look at dictionaries, the full dictionaries, and maintain those counts and so on. It's just that you have to really build algorithms which are faster, which really do all of these things really quickly. Okay? There's no standard dictionary. There can't be because of course, there's a Merriam-Webster's dictionary, which is the standard dictionary that people use for English, right? But there can't be a standard dictionary because new words keep coming in. Okay? And as far as NLP is concerned, you just don't care about those words which exist in a dictionary. So on average, in English dictionary, in Merriam-Webster's dictionary, there are like 2 lakh words, right? But there are many more on Wikipedia. Like Sachin Tendulkar is also a word which will not exist in a dictionary, but it's a useful word. You need to care about it also. So there you build your dictionary using all Wikipedia titles. So you go to Wikipedia, you crawl everything, you dump everything, and then whatever the titles, you use those also as dictionary words. So you have to keep growing your dictionaries like this. There is no standard dictionary that one can use. Oh, that's a good question. So it's nice that you asked. So that I can talk about because there's some learning there, right? So chatbots, right? I put it in the last bucket because it's not easy to do it in a generic way. Okay. So in the sense that if you ask a chatbot, "Hello, how are you doing?" Right? Of course, one way to really reply back in a chatty session. So chatbots are of 2 kinds. One which really just engage you in conversations, right? In India, we have a lot of people to talk around to, and therefore we don't need a bot to talk to. But in US, people are usually very lonely, okay? So they feel the need to talk to a chatbot also, okay? But anyway, so one kind of chatbots are which just engage in conversations. That's all. It has to do nothing, and it's just gossip chatbot, you can call it, right? The second one is informational chatbots, where you basically give out some useful information. So informational chatbots are usually domain specific, right? But these chatty chatbots or the gossiping ones are the more interesting ones, right? And Tay was Microsoft's efforts towards that domain. So let's build a chatbot such that, if you ask it, "How are you doing?" it will reply back, "Oh, I'm doing good. How are you?" Right? How has the day been, or how has the weekend been, and so on. Okay? So now, of course, the obvious thing is, how do you build such a chatbot? So one way to do it is to really gather all the Twitter conversations, right? So if somebody asks you on Twitter, "How are you?" right? What do? You reply back on Twitter saying, "I am doing good. How are you?" Okay? So those replies can actually be used to reply back. If somebody else also asks you, "How are you?" you learn that, well, you can answer back saying, "I am doing good," right? But the problem is that on Twitter, a lot of people say nasty things also in replying back, right? So, and then if you learn those nasty things, then, the chatbot also learns nasty things. So then it says nasty things, right? So, and that's what happened when Microsoft launched the Tay bot. Okay? People started asking nasty questions. So basically, they started asking things like, what do you think about blacks versus whites in the USA, right? And then now, the nearest match on Twitter, whatever you can get from Twitter is whatever you can get. It could contain all kinds of nasty things. And that's what Microsoft's chatbot would also say. Of course, it's not as simple as that, but I'm just simplifying for the sake of this conversation. So, which causes issues. Then as Microsoft, you cannot put out stuff, nasty stuff, right? And therefore, Microsoft had to take back that bot. And that's why I mentioned that it is one of those things which is still in research, and there's no commercial software to do it generically. AI and NLP are practically similar things. So here it is more of NLP, more of natural language processing rather than artificial intelligence.
You have a brief high-level overview of where this thing is going. NLP can be used for a wide variety of things. It is not that it is perfect, needs a lot of refinement. Simple things like color can be a problem. People are trying to improve it. However, bulk of the work is happening in the English language. So if you guys want to do something in your local language or something or local dialect, there is scope for a startup company right there. Question is, who's going to pay for it? That is obviously the end question, right? Now, having said that, today I actually did something interesting. I thought, let me send you something called text blob. So see if you can open this website. I think what's his name? What Sukanya must have put it up for you guys today. Now, you have to understand something that, remember I was telling you that there must have been somebody who must have tried to analyze information and words and so on. So these guys have made ready-made libraries. NLTK is Natural Language Kit, which has been developed by Stanford University. And they keep appending it from time to time. So if your NLTK kit is not running, it's not because of you. Somebody must have appended it at Stanford after doing some research. So you need to keep that in mind. Text blob is something similar. It's a little bit faster than NLTK because it doesn't have all the features, but it has some good features in it. And of course, Pacey is the fastest. So all of these things are there. So when you go outside the class and you suddenly see on data on Medium or someplace this being used, you must be wondering what is all this? We didn't talk about it in class. It's nothing. It's just picking up the library functions. And it has got a huge corpora. What does the corpora mean? What is the corpora? It has a huge corpora of documents, a collection of documents at the back end. And at the collection of documents, it has the rules. Is a word, D is a very common pronoun, like stuff like that. All of the things it has got, the rules are written at the back of it. So that is why the corpa is, it has got, for all of them have their own corpa. So all of them have their own corpa to start with. Now what I'm doing in the beginning here is something simple. I'm just going to kind of download some files here. So as you can clearly see, it's nothing much. I have not done here much. Just put in the usual files. Some things I downloaded when I ran into problems because I was running it, it was not working. So I was googling and figuring out what is wrong with it. So some of the NLTK toolkits were downloaded from there. Having said that, the next thing that I did was, it is a Python library and offers a simple API. So I put some commentary for you guys to keep with you. It performs methods and performs basic NLP tasks. A good thing about it is that they are just like Python strings. So what are Python strings? What are Python strings? What is a Python string? You have a string, right? In Python, you have a string. So if you have a string in Python, what does it look like? You just have this, no? Sorry, this is not working. What is Python string? So you have got, it is a book or a blog, right? So it's a Python string, str string. So that is what it is. If you do this, it can lead to a problem. You might have seen this. It's a book. If you do this, it can lead to problems. What problem will it lead to? This is saying it is getting closed here, but the loop is not getting closed. So we have got that sorted out there. It has got, so I got a text blob here and I picked up the 11 characters. As I said, I'm starting from very basics. I know this must be very basic. You have done this 100 times, but I'm starting from very basics just to ensure that we kind of are on the same page. So you have got that, and you can see I've used, on the strings I have used an upper. Upper is basically a built-in command that will help you make it upper. And of course, the next thing is to concatenate. So if some of you are running into any kind of problems, I have also told you where to download the corpa, because sometimes without downloading the corpa, it may not work. So if you're running into a problem in the class right now, then that is because that installation is not happened. So if you run the code, you will know if you're running into a problem. Okay. So if you're running into a problem, then you need to go to Anaconda prompt and download the corpa. Then we get to the real work. The real work is tokenization. The tokenization is to divide the text or sentence into sequences. So create a text block object and pass a string with it. So you're creating a text block object, passing a string with it. Call functions of text block in order to do a specific task. So you're calling the function to do a specific task here. So this is my string. This is a text blob string. So you have to be very careful. This is not a regular Pythonic string. It's a text blob string. And have you heard of JSON format? Yes. Just like you have a JSON format for certain things, especially if you are doing blockchain, you have to put things in JSON format. Here also you will see this is a text blob and that is there. And you can see I have tokenized it. So blob.sentences. So it has taken the sentences wherever there was and it has made them separate tokens. So that is where very, very simple commands, blob.sentences. You can further break it down into words. So I could do that. So I went to the next level and I further broke it down into words. So I just took the first sentence. That is why I have written 0 there. If you wanted to pick up the next sentence, you could have written 1 and you could have broken down into words. Very, very straightforward, simple, broken down into words. So tokenization of sentences, tokenization leading to this. Now comes the interesting part. The interesting part is we only want to take out the noun phrases. We are not interested in taking out anything else, but only the noun phrases. So if you want to take out the noun phrase, you must first identify the noun phrase. You want to analyze the who in a sentence. Now I did this. I said Enlightened is a great platform to learn data science. Noun phrase, print NP. First of all, can you please check and tell me that all the words are nouns? Are they all nouns? Are all of them nouns? Yes, no. Which of them are nouns, which of them are not nouns? Sorry? Great is not a noun, right? It should have been an adjective. This shows you, what I purposely bring this example is because this shows you that end of the day you are dealing with machines. End of the day you are dealing with machines. Somebody must not have at the back end been able to get to that level of granularity where we can clearly say that great is not this and it is this, right? So end of the day, you are dealing with machines. That is why it is picking up some stuff which it should not have picked up here. Going forward, it's quite simple. After that, I picked a great platform. I went around and I did some tagging. So this is what the thing I want to talk about, parts of speech tagging. So in the part of speech tagging, what you have seen is, it tells you what these things are. It tells you what Enlightened is a great platform. So I've done the tagging for all of them. So all the tags you will notice, they are all capital letters. All capital letters. So anybody can tell me what is VBZ mean? What does VBZ mean? So when you run this, you get something called VBZ. What does VBZ mean? So let's go back and check on the pen track. Where are we on the trend track? VBZ. What does VBZ? Verb third person singular present. Verb third person singular present. So if you don't know the meanings, you need to have this ready reckoner. Some of them are very easy, noun, singular or mess. Let's go through a few of them just to kind of familiarize how to read these things. So if you go back here, you have got JJ. What does JJ mean? I mean, it's a JJ. JJ means adjective. JJ means it is an adjective. Now go back and check if what he's saying is correct. Is great an adjective? Is great an adjective? I agree with you too. What does VBZ mean? Let me see. VBZ is version third person singular. That is means singular. R means plural, right? So you can see it is singular and plural. Platform is a noun. Learn is verb again. I think it's a simple verb. VB, verb or base form is noun. You can clearly see it. You can see signs. You can check the full list. I have left the full list here as well. Okay, then comes is the process of word formation added to the base word. So I've kind of made the base word. You can make words out of the base word. So blob dot sentences one dots word one. What will this print? Can you tell me what it will print? Word dot sentences one dot words one. What will that print? In the first sentence, it will print the second word. Or will it pick up the second sentence and print the second word? Think for a minute what it will do. So if you do this, blob dot sentences one. It had been 0, it would have picked up the first sentence. 1 means it will pick up the second sentence. And when it picks up the second sentence, you can pick up the second word inside it. And then you can say, make it singular. So I first picked up the word, the answer was helps. And if I want to make it singular, I can say singularize it, answer becomes help. So from helps, we have gone to help. So you can see it's fairly easy to use. It's not something that requires a lot of brain power. I mean, I'm just starting you off. It's less than 1 hour in the class. So kind of showing you some of the basic things that you can use. In fact, you can use some of this for your projects. You know, a lot of challenges that you're facing with project is in terms of finding data. If you are doing ML kind of work, if you are doing convolution neural network kind of work or image recognition, everybody talks about object detection. In some form or the other, you are always talking about object detection. The problem is that many of those things are not easy to do. Either the mathematics behind it is very complicated for a 6-month time frame or 7-month time frame. But one area that you can explore is try to make sense of using machine learning, try to make sense of customer feedbacks, reviews, Twitter accounts. So once I had a bunch of students work in 2019 before the elections, I had a bunch of students analyze the Prime Minister's speeches. So they picked up the speeches of 2014 and 2019. And you can see the marked difference. In 2014 speech, he talks about corruption, price rise, a bunch secular country, all of those things. Those are key 4 or 5 words. And in 2019, he talks about what? There is silence in the class. In 2019, what does he talk about? Balakot, terrorism, Pakistan. That is what he talks about. So these guys went and picked up all his speeches and they just did what I'm telling you. They stripped it into small chunks, took out the common words across documents and sent, this is what he's talking. These are the key words we have found in all his speeches, concurrent across all his speeches. Top 5 words I'd asked them to find out. So a very, very interesting thing, because you see, sometimes numerical data can be misleading. And I'll give you an example right now in the class. Why it can be misleading? So all of you know, sorry, today it seems I am having a bad day. Every pen I pick up has no ink in it. So y equal to 5 plus 6x, right? Y equal to 5 plus, or let's make it yi equal to 5, 6x. Yes. And I tell you that the r square value is 90%. Okay. Now, looking at this equation, what do you remember? What do you think of? Something you've seen on this in this program? Unsupervised, supervised learning? Linear regression, right? To think about a linear regression. But at the end of the day, this is the mathematical model, right? Now, the question is, what is the difference between mathematics and statistics? See, that's the fundamental point here. What is the difference between just doing maths and counting 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. That's mathematics. Then what is the difference between mathematics and statistics? Statistics should be also called mathematics only. So, we are in this, you have been doing so much of this stuff. At some stage, mathematics and statistics starts to get blurred, right? I mean, sometimes you say I'm doing mathematics, sometimes you say I'm doing statistics. But trust me, there is a very, very significant difference between the two words. Mathematics, I gave you an example. 2 plus 2 plus 2, 6. Right? Statistics, you are talking about this. And what is this? This is a math. If you look at this model standalone, this is a mathematical model. I agree with you. This is a mathematical model because this mathematical model does what? It relates x to y. Right? Then where is the statistical part coming out of it? Because if you remember you just told me in the class this is linear regression. Yes or no? And linear regression, you and I both agree it coming from statistics. So where is the statistics part coming from? Yes, we arrived at it based on a sample, but there's one more interesting thing. You see all these numbers which you have written on the board here, 5 plus 6, are they set in stone or are they changeable? Why are they changeable? How can they be changeable? Because 2 plus 2 plus 2 in mathematics is 6, no? I cannot make 6 equal to 8, correct? 2 plus 2 plus 2 is 6 only. Then how can this change? Remember something that we always ask you to do? Calculate what? Confidence interval. So when you calculate the confidence interval, you say the confidence interval of this is, let us say, -3 to 8. And the confidence interval of this is, let us say, -1 to 9. This is what you say. Which means that these numbers are only an estimate based on the population, but these numbers can vary between -1 and 9. It can vary between -3 and 8. So mathematically they are mathematical numbers, but this entire model is statistical because the numbers are not constant, the numbers are going to change because the sample will change. Otherwise, nowhere else in mathematics, if you go back to your school days, nowhere would in class 9th or 10th, we write so many equations, x plus y equal to z, this and that. Did ever any faculty ask you to compute confidence interval in class? 10th, 11th, 12th? No, because we were dealing with pure play mathematics. We were not dealing with statistics in the first place. Now you are dealing with statistics. That is why each and every number that you have has got a confidence. This is called point-wise estimate. And what is what you were saying today in the morning about estimate? This is estimate, but these estimates are all beholden to the confidence intervals. Now, why is that point important? The point is important is that when you are dealing with things like this, like language and all of that, we are talking about statistical models because we are also not sure that what we are saying, the system is picking up, is it going to be 100% like I'm saying is. It could be that in some other model, the word is considered to be a noun, whereas is always a verb, right? Is always a verb. So there's always going to be some degree of uncertainty when we are doing the tagging for these things. We are going to always, it's never going to be noun 100% guaranteed noun. We are saying it is 70% or 80% chance the word is a noun. So you might look at a bunch of words and say, तो वो noun बोला था, ये तो verb है. What is happening here? So that is where the statistical element of this whole subject comes into place. We are still not sure about how to break things down and put it in place, specifically because each of these words have got many inks, running, playing, all of those things are there. So there is like displaying, this comes before playing, displaying. So replaying, playing. So all of those challenges are there, and that is why we are dealing with statistical model, not so much as mathematical models. There is a confidence interval behind each one of these things. Having said that, the next part obviously was to try and see how we can take the words and how we can pluralize the word. So just take the word platform, and I wanted to just pluralize it into platforms. Tying back to what I was saying here, that if you guys are doing any kind of statistical model in your capstone project, then if you can do any analysis on text, which can circumvent your which can bolster your findings. So whatever mathematics is saying, your equation is saying, the linear equation is saying that the sales is dependent upon, let us say, disposable income. Sales is dependent upon disposable income. If you can have any kind of English argument with all this NLP at the back of it, it only strengthens your argument in front of the client. The client feels that not only are the remarks, the qualitative remarks also saying that, the mathematical remarks are also saying that, right? That is the reason why we teach this course, because this part you already know. This part you already know. But the important part is to understand that it is not by itself enough to justify sometimes many actions, because sometimes numbers and what the comments are being coming are different. So for example, I'll give you your own example. One day there was this, I was reading the feedbacks. I always read your feedbacks. I was reading the feedback and somebody had written some comment. I could not understand the comment and I couldn't understand the rating. So I said, what happened? How did this go wrong? So I called up the program team. I said, I can't understand the rating and the comment. So either the comment is right or the rating is wrong. One of the two things has to happen. So this person, what the program team called up the student to find out. I don't know who the student is. And the student said, I actually wanted to say this, but when I was marking the person's ratings 1, 2, 3, 4, 5, I mistakenly marked it like this. Right? Mistakenly. So data at times can be wrong. Numerical data can be wrong. And when you look at NLP, it can tell you, hey, you know what? Your numerical is not matching with your the written feedback that you have given to the faculty. Okay, you're saying, oh, he's a very good faculty, blah, blah, blah. Suddenly you see you giving him a rating of 1. Right? If that is your understanding of 1, I think that's a very good one. Having said that, that's good. Then we move on to the next thing. Hey guys, it's 3:20. Is the speed okay or am I going too fast? Speed is okay. Generally, the students in my class control the speed. I don't control the speed. The only reason why I'm going a little fast because all these things are a little bit simple, just adding one command. At any point in time you want me to slow down, please let me know. And any point of time you want to go out and have coffee or tea, just let me know. We don't have to wait till 4 o'clock to go and have coffee. Okay. Don't worry. I will still get the content done. That's my job. Okay. So having said that, let's look at what is lemmatization meaning. So lemmatization, what happens is that he takes the original word called running, and it's a verb which we already know, and we say lemmatize it to a verb. So don't keep, see, the other important thing is, why are you saying lemmatize we? What does we mean? We here represents verb. Why should it be lemmatized to a verb? Because if you don't write we, it could also be lemmatized to something else. What? Because it could be lemmatized to maybe an Italian word, and the Greek italics word, which we also have, which is the birth of English language, where Shakespeare comes from. So that's where the issue is, that you have to sometimes tell them what you want to lemmatize. Then you have got n-grams. Now, n-grams are actually quite interesting because I will be using them heavily for classification today and tomorrow. It's also there in your internal and external project. What do you call it? Labs. It's also in that, and then it is also in your massive major project. Okay. So I would certainly suggest to you that, so we talk about n-grams. So what n-grams is very simple. Before you do that, let me try to explain to you the concept of n-gram on the board, because this will be a lot easier on the board than me trying to explain it to you here. This is a book, right? So you have got the first word, the second word, third word, fourth word. This would be called n-gram 1. What does n-gram 1 mean? Only one word at a time. Now you look at n-gram 2. So n-gram 2 would look like this. This is n-gram 2. So now the n-gram 2 is going to be, this is a book, right? I could have made it into 3 also, right? You could have done that also. So that is what here it is. I gave the command for 2, so it made it into 2. Enlightened is a great platform like that. So that is where it was. And then you have got sentiment analysis. Now comes the fun part. Sorry? Classification problems. So what we can do in the classification problem, which you will see, is that we will convert these two words into numbers and we will bind them together. So that will have a new vector and we will say this vector. Okay. So now comes the interesting part. This is what I had been waiting for and I wanted to get to. Sentiment analysis. Everybody wants to do sentiment analysis. In sentiment analysis, there are two parts. What are the two parts? Polarity and subjectivity. So what does polarity mean? Sentiment is basically the attitude or emotion of the writer. What is your attitude? Are you a positive writer or a negative writer? Do you think in a positive frame of mind or think in a negative frame of mind? So that is what sentiment is. In addition to sentiment, you also have polarity and subjectivity. So within sentiment, polarity and subjectivity is there, and polarity varies between -1 and 1, where 1 means positive statement, negative one means negative statement. So naturally, if you are looking for somebody who has +1, you say these sentences or these phrases are positive. If negative, it means negative. Now this kind of stuff is what you can use in the capstone project, so as to speak. Yeah. Yeah, it is doing a background calculation for that. So it's a detailed calculation. It is taking some of the words which we already like, good, great, all of those words it is taking, and then it is making this thing at the back of it. Yeah, it's a positive thing. Subjectivity is where you are talking about like contextual. The contextual part, it doesn't do a very good job of it. It's picking it up, but it is not doing a very good job of it. So let me give you an example of subjectivity. So like judgment, where opinions refers to factual information. So I'm saying this is a good book. This is my opinion. Is it really a good book? It is subjectivity, na? I think statistical NLP is a boring class. Somebody might say NLP is a great class. It's subjectivity, right? So that subjectivity tries to map. Polarity it is very good at doing. Subjectivity I'm not so comfortable with any of the three packages, because again the way it has been designed at the back end, the algorithm which is being used, it is not consistent across all three. All three meaning no, it is paid on points. So it is bigrams and trigrams. It will take the measure of bigram, because individual words it has no meaning. Right, you always want to look at bigrams. Is great, are great. Are great will have more subjectivity. Are means more people think that this book is great. Is great means only one person thinks that the book is great. That is. Any other questions? No, it's great. So anyway, so that is where we are. I tried to do that here, and I was seeing sentiment of 0.8, subjectivity of 0.75. So it says that it is fairly able to pick up the subjectivity and the polarity, and it says polarity is 0.8. What does polarity of 0.8, what would it mean to you? Positive. I'm already saying that Enlightened is a great platform to learn data science. It helps community blogs, hackathons, discussions, etc. We can see polarity is 0.8, which means that the statement is positive. Mostly is a public opinion and not something that is a factual information. No one has ever said that Enlightened is perfect or Enlightened is the only place in the world where you can go and learn data science. Having said that, FYI, the reason why I'm using the word Enlightened over and over again is because that's my firm. So that's what it is. So I must be wondering why have I chosen the word Enlightened. That's why. You can also do spell check function here. So you can check the spellings. You can look at spell check function. You can do word spell check. Platform ka spell check hai. And the next very important thing is about summary of text. Summary of text is actually quite interesting. Let's go and see. Oh, this one you mean spell check equal to 1, right? So it's picking up the 4 and saying it is right. 1, 0. That is what it is. Okay. So we are kind of going through this in a nice way, in a neat manner. And then I have got some stuff here and here and here. Let us see what we want to do here. Let us go and look. Where did we go? Where did we go? Where did we go? Did we do the n-grams? We did the lemmatization. Okay, fine. Creating a short summary of text. You can see the summary of text is here. The text is about, you can create a short summary. So in the short summary, I have written a simple word tag in blog tags. The keywords is, the text is about platforms, industries, platforms. Again, so you can see it has come back twice. Platforms has come back twice. Communities, forums. So it has come back twice, the word platform. You can create short summaries. Do you know where this is helpful? Any idea where this is helpful? One place in your workplace where this is helpful. So one of the areas is that I used to find this kind of stuff, which I wish it was there when I was doing this. So I used to work in Hong Kong, and the problem is that I used to go to attend a lot of conferences on behalf of my office. So they used to give me a lot of research material and stuff like that. And most of the material would come either hard copy, or they will, if you request, they will send soft copy of it. Now, who is going to sit and read 500 pages of research material? Because every week some conference is happening in some part of the world. Now, I am not going to keep sitting and reading it, right? So one area which is helpful, it could have been helpful, is that instead of you writing so much text, you take the entire text from the Acrobat Reader or Word document or wherever else, put it in there and say, what are the keywords or key themes this is talking about? That will at least give you some sort of summary if that is an area of interest to you or not. Now, if you already know you're interested, of course, read the full thing from beginning to end. But if that is not something, an area of interest, then you could have done that. But I didn't know Python at that time. And I didn't know NLTK or NLP, any of these things at that time. As I told you, I planned to be just doing normal regular work after my MBA. So now I feel that if I had known that, I would have saved a lot of time. Because large document, by the time you finish reading the 10th passage, you forget what is in the first passage. And then I used to have a boss who was old school. So he would say, I want a summary of everything which has been written. So I used to keep every para, I used to have to make summary on the side, because at the end I have to type it down and make it in 300, 400 words, he will say, because he was a chairman. He said, I have no time to read so much, but I want to know everything. Right? So it used to be a pain. If this had been there, it is much more faster to do, right? One interesting addition on top of this that you can do is web scraping. What is web scraping? Web scraping. Websites, you can scrape the data, all the textual information from the website. FYI, just be careful, it has now become illegal. So if they find out you're doing web scraping on some of the websites, your IP can be blocked. It was not illegal 3-4 years ago. So when we used to do this class, we used to web and social media analytics. We used to go into Twitter, take out all the messages, and we used to analyze in the class in the real time, right? And scrape the whole thing and analyze in the class in the real time. But now it has become illegal. So you have to be a little bit careful of how to use that. But you should, so just when you're doing this kind of projects, just be careful about it. That's all I was trying to say. And then one of the interesting things here is that you can also check the language of a word. So you can pick up the language of, I picked up this words here, and I picked up this word, made it into a text blob. And it is Chinese. And I said, hey, let's convert this Chinese to English. And therefore, I convert it to English. And what is the English translation of the Chinese verb? This is cool, right? This is absolutely cool. Everything is going well. What happened? You want me to write even bigger than this? Now I think I'm fine. I think I'm fine now. You guys can see, right? At the very end. Yeah, that's fine. Perfect. Okay, now let's start doing some classification models here, which is going to be crazy, but it's okay. Let's do. So this was all the basic stuff I wanted to cover with you. Wanted to just go through singularize, pluralize, pick up word, do some basic sentiment analysis and stuff like that. But that's not what this class was about. This class last time I checked was statistical NLP. Still now I have not done any statistics in the class. So I'm beginning to wonder if I am teaching the wrong class. Having said that, I created some training data set. Now in this training data set, I didn't create it, I picked it up from somewhere. But some interesting thing about this training data set is that you have got these sentences, and next to the sentences, I have used negative, positive, negative, positive. So these are assigned not by anybody, but by the user. So I am the user. I have created this data set. So I have said, Tom Holland is a terrible Spider-Man. Tom Holland is a terrible Spider-Man. It's a negative sentence. You agree with me? Then I have got a terrible Javert ruined Lee miserables for me. Again negative. The Dark Knight Rises is the greatest superhero movie ever. Positive. So I did this on my own, just took some sentences and I classified them as good or bad sentences. And then what I did was I did the same thing on the testing side. On the testing side also I did the same thing. I kind of did that there as well. Text provides an inbuilt classifier. And finally, I came to do what is known as, took that and I went into text block classifiers and I created what is known as naive Bayes classifier. And I took a naive Bayes classifier. Have you by any chance heard of naive Bayes? Yes? You know what it is? Okay, so tell me what it is. Okay? You are very close, very close. I think almost right to the right point. Anybody else, what is naive Bayes? Have you done it first? Or am I asking a question which I should not ask? See, tell me honestly, if something has not been covered, then let me know and I will cover it. But so naive Bayes, what is naive Bayes? Zero correlation between features. Okay. What else? Which is independence, which is what he was saying. Yeah. But what is naive Bayes? Why do we use naive Bayes? I think you were taught in supervised learning, right? Next week, I'm teaching supervised learning in AI/ML in Gurgaon. So, naive Bayes. Any thoughts? Very good answer. Probabilistic model based on Bayes theorem. So, how does it work? Like, what is happening inside it? See, logistic regression, if I ask anybody, they will immediately say, such a classification problem, 0 and 1. That's what people will say. Yes? The minute I will ask you about regression, simple linear regression, I showed you on the board, everybody would say, so the prediction problem, X you give, Y I will predict. So given A, what is the probability that B can occur? But then why are we calling it naive Bayes? You could just call it Bayes now. So what should I write on the other side? Right? So this is how Bayes theorem works. Simple Bayes theorem. And to refresh your memory a little bit, you have got two sets A and B, and this is A intersection B, right? So what you are writing here is following: P A given B is equal to probability of A intersection B divided by PB, and then you are saying PB given A is equal to probability of A intersection B by PA. And then finally you are saying the following, that this implies that probability A intersection B is equal to probability of A given B divided by PB, no, not multiplied by PB, sorry. So it will be multiplied by PB, and you are saying that probability of A intersection B is equal to PB given A into probability of A. Yes, this is what you are saying. And then you are saying that these two things are equal, and because those two things are equal, what do we end up doing? Probability of A given B multiplied by probability of B is equal to probability of B given A multiplied by probability of A. Yes. And then that gives you probability of A given B, which is equal to probability of B given A multiplied by probability of A divided by probability of B. Yes. Right? So this is what is known as simple Bayes theorems. And what's naive about it? What you are saying, what's naive about it? So think about it for a minute, what's naive about it? Okay. So let's see how this will work. How many of you have life insurance contracts? Life insurance for your life? All of you? Some of you? Life insurance? So as life insurance, when I'm sitting and doing your life insurance pricing policy, I use the following logic. I suppose you come to me and say that I want life insurance between the years 50 and 60. The person should be first alive till the age of 50. Then only if something happens will the person be given any life insurance. Correct? So, there is the condition there. It's not as simple as probability between 50 and 60. Probability is that you are going to be paid conditional that you are at least at the starting of the contract alive. And the contract starts at what time? Age of 50. So, it's no more a simple probability, it is a conditional probability. Just like we say, it is conditioned to you getting very good marks in your +2, you are going to get admission into college. It is not just passing, but it is the precondition to that. So, conditional probability is heavily used in sequential models because everything is a condition. The sky is blue. The sky is blue is very easy for us to say, but for a system to detect, there has to be some probabilistic model which tells it that when you have this kind of sequence, the sky is, it should automatically point to blue. It is not talking about the sky has a rainbow in it. It's only talking about the color of the sky. So probably this is important. Bayes theorem is important. Now that you understand how this Bayes theorem works, just wanted to kind of draw it from first principles for you. What we are basically doing was the following. Would it be okay if I write the following? PA by B is directly proportional to PB given A into PA. Would it be okay? Yes, no. What have I dropped? I have dropped the denominator. Because I have dropped the denominator, my equality sign has become inequality sign. Got it? That is one of the important things here. Now what I will say is PA instead of B, I put in multiple conditions. θ1, θ2, θ3 and explain that to you in a minute. θ1, θ2, θ3, this will become what? θ1, θ2, θ3 given A into probability of A. So I have replaced B instead of having one condition. How many conditions I have now got? 3 conditions. And what he was saying was that you can further replace it down by saying P θ1 into probability θ2 into probability of θ3 given A multiplied by probability of A. How is this possible? Zero correlation and independence. So the conditions are independent. So because they are independent, you are able to do this. So that is why you are able to take, because they are independent, all these 3 terms are independent, but they are all conditioned on A, you are in a position to write it like this. And this is the mathematical model that we will be using. In fact, I have a full problem for you to do in Excel. So whenever I teach these kind of statistical models, I prefer to do one problem in Excel with words and sentences so that you understand what is happening. Our friend here can do it in 1 second. But we have to understand, just take the same problem, what is the mean and variance of 1, 2 and 3? Understand what is inherently happening. So I'm setting the stage before, because I know it's hitting 4 o'clock and I also know it is Saturday today, so we have to have coffee. So I'm setting the stage for that. So this is where you're talking about naive Bayes, and we will work out 2 problems in the class today in Excel before we do it in Python, so that you understand how that part of Bayes theorem applies to text. You, I'm sure, understand how it applies to numerical data because it has been covered where? In your which course? Supervised learning. Okay. So here what I will just finish this off and then take a break. Here what is happening is something simple. I have got a naive Bayes classifier. I am training it up. After training it, I am saying the following. Training it and finally asking it to do some simple things for me. I said, you know what? Classifier, show the top 3 informative features. So what are the top 3 informative features it is showing me? The top 3 informative features it is showing is that it contains is equal to true. What does this mean? Contains is equal to true. If a sentence contains is, contains means the sentence should contain is. If a sentence contains is, if is present in a sentence, in the next sentence, if A contains A, false means what? A should not be there in the sentence. Again, you can see terrible, it should not be there in the sentence. So what it is saying is that if that be the case, the positive to negative ratio is 2.9:1. So you can see that the positive sentiment, if this word is there, is there, the chances that your sentence is a positive sentence as compared to a negative one. If this word is not there, the chances that your sentence is a positive sentence is 1.8. If this word is not there, it is also going to show us 1.8. So that is what it is doing. And then I just made up a word right here in the while I was typing this down. Text blob, the weather is beautiful, classifier, and it tells you it is a positive sentence. And pretty much ended this classification problem there itself. However, it is not that simple. And I have also put the pros and cons. So you can see the pros and cons of some of the things which I do. NLTK and pattern therefore makes it simpler for beginners by providing an intuitive interface to NLTK. NLTK is a lot more complicated. Language translation detected, powered by Google Translate, not provided by Spacey. Lot slower compared to Spacey, but faster than NLTK. Does not provide feature dependency, parsing, word to vector, etc. Word to vec you will learn when you are doing the next course. The next course is sequential NLP, where you will start talking about how to use deep neural networks in order to do word to vec translation. So this was something, just an overview about using text blob, about how different types of text can be analyzed and we can start working on. When we come back after the break, we will then talk about something more intense and challenging about headline news analysis, some more statistical stuff. So this was just to get you started on the journey of NLP. Having said that, couple of things. There is a file which I have given you, and that file is known as news headline analysis. So just open that file. Okay, did you get this file? So there is a file on the top saying news headline analysis.jp. Yes? Okay. In the folder, or not in the folder, I think it's not in the folder. In the link provided by Sukanya, there is a massive CSV file which has got 2.7 million headlines. Yes, you would have been able to see that as well. Sukanya would have provided that link to you. We were struggling to upload it, so that's why I know that she has provided the link. It's there. Is it there? Yeah, it's there. So it's there. What I want you to do is first download that file or somewhere where you can access it. And second, I want you to read the file in. I want you to read the file in. Because the reading of that file, the database to read it will take us half an hour. So if you set it up now, then by the time the break ends and we are all ready to come back and start, we can do something with it. Okay. So you want to go ahead and read the file in. It takes a huge file. Yesterday night I was testing the files before coming to class. It took me 2 hours. I was so frustrated because I couldn't do anything, and leaving the laptop would have meant it would shut down on its own. So I was like sitting there till it was 1%, 0.5%. And before you do that, put it on hardware accelerator, GPU. Because I learned that this is much faster to do it. It just condenses time. So go to runtime settings. Go to runtime here, and in runtime you will see change runtime type. Right? So set it equal to GPU. Hardware accelerator equal to GPU. Okay. So that's important. That just saves you a lot of time. So once you are done with that, let's do a quick class recap of what we learned, what we didn't learn, and what we are trying to learn. And then let's take a break, come back and start getting into some really heavy stuff. In fact, the news analysis is you'll see this file. It has got BJP, Congress, Aam Aadmi Party, everybody is inside it. So it's a lot of fun. You will understand it's a lot of fun to analyze the headline. What did they say? When did they say? Why did they say? And if you guys are, if still time permits and you guys tell me you are still charged up to do statistics, then we will take this forward and solve 2 Excel problems on that. Okay. But it's completely up to you guys how you feel. Is it running now? The files are running. Hey guys, speed theek hai? Speed is okay. Speed is okay. Anytime you need me to control, let me know. Concepts, chal raha hai. It will take time to absorb. It's not something that will come. A little bit of practice is needed. Unlike some of your heavy subjects like deep learning and all, it's not that heavy because you're already using ready-made things like naive Bayes and all, which you already understand. It's more about applying it in Python. That is the challenge here. The challenge here is not so much in terms of, it's too much of heavyweight lifting in the brain. They are very, very simple concepts. Because you can't do complex concepts because we have not built it inside those libraries. So simple concepts, but the Python is the main challenge. Okay, downloading. I'm just waiting for it. Okay, then let's do a quick recap because while it's downloading, we can't do much really. So the quick recap of the class was, where did we start the class today? And I'm not doing the recap, you are doing it for me. What is the first question I asked in the class today? What is stats? Second question, what is a model? Then what did you learn in the class today? So two things you learned is stats and model. Then what did you learn? What are NLP types? What else did you learn today? Statistical and difference between statistical and mathematical. Yes. What else did you learn? How to compute the mean and variance of 1, 2 and 3. Right? Yes or no? Yes. So, I mean, that I always check. Because sometimes I feel I have already taught you and then I don't know if I taught you or not. The next thing, what else did you learn today in the class? You learned about NLP. You learned about two kinds of NLP, statistical NLP and sequential NLP. In sequential NLP, you go with recurrent neural networks and all of those things. Then you learned about sentiment analysis, parts of speech, tagging. You saw parts of speech be getting tagged, noun and adjective and so on. Sentiment analysis, I did it on the board for you. Then you learned within that about polarity and subjectivity. The polarity is +1, people are positive. Polarity is -1, people are not positive. The subjectivity varies between 0 and 1. It is not about factuality, but it is about subjectivity. Then after that, you went from there to understanding how to make tokens. So you took the sentences and chopped it into sentences or also into words. You learned how to make it stem and lemmatization, you learned that. Then from lemmatization and stemming, you came up to learning about how to make it singular, how to make it plural. I showed you some basic stuff about spell check and stuff like that, how to make the spell checks work, etc. What else did you learn? You learned that there are 3 different types of library functions out there. The 3 functions are NLTK, Spacey and text block. So I was using text block today the whole day in the class. Also parts of NLTK were used. If you see the library functions, you will see NLTK has been downloaded, certain parts of NLTK. You learned a little bit about Bayes theorem. You learned a little bit about naive Bayes theorem. I have not really deep down into it. I will do that. It needs a deep down into it. You learned a concept called bag of words, which you have not yet seen. You will see after the class. But bag of words is nothing but a bag which has only got words in it. The meaning and the sentence and the grammar is lost. Another important thing you learned was that these are machines, they are not perfect. So you saw one example where we were trying to pick up nouns, it also ended up picking up verbs, right? So we are machines, these are not perfect. The key important thing I told you in the class was that you can use some of this information to supplement your machine learning projects. You can say that, NLP is saying that customer data is saying that it is negative, customers don't want to buy. But NLP is also telling you what customers don't want to buy. They don't like to buy sandals, they don't like to buy shoes, they don't like to buy shirts. Those things you can use to do it.
This brings us to the end of this tutorial on natural language processing. Thank you very much and have a great learning ahead.
I want to introduce you to Great Learning Academy, a free initiative by Great Learning. You can access over 200 plus courses with 1000 plus hours of free content on trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion. Check out the link in the description of the video below. If you haven't yet subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell so that you do not miss out on any new updates or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video if you have any queries or suggestions, and I'll respond to your comments.